have to go for a parallel bridge, or if it is T-girder bridge, then we may be able to add T-girder, one more T-girder, and extend the width of the superstructure without much problem. So the future widening provision also should be kept in mind when we are doing the planning. Then coming to the aesthetics, though the conventional order of priorities in the design, that is the safety, economy, serviceability, constructability, and the aesthetics comes probably last, but we have to pay attention to appearance also. So maybe the additional cost of about 2% for short span and only some 5% for long spans, but if you are able to get some good looking bridge, that will be quite interesting. So it is important that the designers are aware of the qualities of bridge that influence the perception of beauty. And coming to economics, that is not only the initial cost, but also the maintenance costs also to be considered. So we may have to do a life cycle cost analysis for the bridge. So what will be the better option? That is the bridge with minimum number of spans, because we have to see what is the cost of construction of the superstructure with respect to the foundation, substructure and foundation. So more number of spans means there will be more number of piers and its foundation. Then fewest number of expansion joint and wider spacing of girder, that will be economical. Why this expansion joint is worrying us? Because like the bridge expands and contracts because of the daily change in the temperature, and the expansion joints and bearings, though they are like small elements, but they are vital because their design life may not be 100 years. So we may have to replace them, and replacing these elements for bearing replacement, we may have to lift a span, or for expansion joint replacement, we may have to close one lane. I'm sure that many of you must have experienced such difficulties when you are traveling over a road network. So we may have to think of providing or thinking of reducing the number of expansion joint. Then what will happen? The type of expansion joint will change. So that's why, like from the strip seal joint, now we are moving to the modular expansion joint. Then concrete bridge construction cost versus steel bridge maintenance cost, that also will have to be seen. So in general, concrete bridge construction maintenance cost is lower, but now with the development of new type of paints, etc., which are available, probably we don't have to do the painting every 5 years, maybe like once in 20 years or 30 years. So that sort of development is happening. So we have to understand what are the other developments happening, because for concrete bridges, like we are providing the cover to protect the steel which is there inside the concrete. But for steel, it is the painting which is protecting or providing the protecting the steel. So the development with respect to the new coating system, that is also very, very important. Now coming to the design aspect, as I told you, I'll be just considering some of the important aspects, that is what are the improvement in the load for the bridge design. As I told you, there are bridges going location, maybe there are something very close to the port where you may see that rather than vehicle moving one after the other, there may be like in a jammed condition. So this condition may be there. So for the design of the bridges, we generally consider that the IRC vehicular loads like IRC class 70R or class AA or class AA, they are moving so that the distance between these two vehicles are something like 30 meters. But in reality, it may not be there. So when it is in a jam condition, we may not consider the vehicular impact, but we may consider that more number of vehicles are there. So what will happen? The bending moment and shear force may enhance like when it is in the jam condition. So that has been addressed, but it is under review to rationalize the congestion factor. Then another aspect is we have added some special vehicle and fatigue vehicle. I will discuss them in detail. And then like last decade, we saw that change in the design philosophy from working stress to the limit state with the introduction of IRC 112. And to support that, like we have the loads and load factor, which is given, the tables given in IRC 6. Then, as we are designing the bridges for 100 years, like it is not that we just do the design for the strength, but also we have to consider the durability for the design. So that is also one important aspect, how we are considering the durability for the bridge design. Then, like as I told you, like the seismic effect or wind effect, these are all important for the bridge design, not only the vertical load, the horizontal forces which are acting on the structure. So the guideline for seismic design of bridges, that is the force-based design using the capacity design concept, then ductile detailing of the substructure, especially the pier, or like we can go for a seismic isolation bearing, that is seismically isolated bridge instead of the force-based design. So these are some of the developments apart from the integral bridge, and also the support condition for the bridges. They are achieved at the site with the help of the different type of bearings. So earlier we used to have like a metallic bearing, but then like we have moved ahead with the elastomeric bearing and spherical bearing, pot PTFE bearing, depending upon the span and the reaction which is to be transferred from superstructure to substructure. So I think I have already talked about it. These are some of the congestion factors which are available in IRC 6 now for a span up to 70 meter or even beyond that, but we are now reviewing this to rationalize it. Now another aspect is the fatigue vehicle. Actually, fatigue becomes important for the steel, which is embedded in concrete, especially like you have a doing some welding of the reinforcement, or if you are using some coupler, etc., for enhancing the length, or also for the anchorage of the PSC girder. So the fatigue vehicle, what we have here is a 40-ton vehicle, and this has been arrived based on the research done at CRRI. And here, the traffic axle load spectrum has been used in arriving at the fatigue vehicle. So this is being used by the designers, steel and concrete bridge designers, for checking the fatigue aspect of the bridge. Now, we have different type of trucks which are plying on the highways. Like earlier it was 2-axle trucks, and now like more number of 3-axle trucks are there, and then like 4-axle, 5-axle, that is multi-axle trucks are there. What I want to say here is that these trucks are, you can say, overloaded, and overloading of the truck, I think we are not able to control it or implement it properly. And now like there is a revision in the Motor Vehicle Act also, and the axle loads have been enhanced also. But what exactly happens is that because of this overloading which is there, like there is an enhancement in the bending moment and shear force, and every time the truck is flying, there is an overstressing of the deck which is happening. So that may affect the life of the structure. Another important parameter is about the special vehicle which has been introduced in IRC 6. Why its need was required is that with the development of these highway infrastructure, there are development of other infrastructure as well. For example, large power plants are also coming, for which like this turbine and other components which are undivided components, they have to be transported from one place to another. They are imported and they arrive at a port and they are taken to the power plant location. And they are generally taken through these hydraulic trailers, which are having a number of hydraulic axles. So the vehicle configuration itself is different, and they weigh something like 300, 400 ton. And generally our IRC loads, which we consider for the design, that may be something like 100 plus some impact factors, or maybe something like 150. So whether the existing road network will be able to take such heavy loads, that itself is a big question mark. So these are some of the failures which happened in 2009 and one in 2011 in MP. This is a balanced cantilever bridge. This is a like simply supported bridge. And another aspect is that not only the overweight vehicle, but oversized vehicle that also can impact and damage the bridges. So the clearances for the bridge deck, that is also very, very important. So this is the new vehicle which has been introduced in IRC 6, and it has 385 ton, including the prime mover of 25 ton. So one has to check the design for this vehicle also, but here you have to understand that this is a controlled movement of the vehicle unless the truck loads. So only one vehicle will be allowed and it will be moving along the central line. Not much eccentricity will be there, and when there is high wind, this vehicle will not be allowed to move. So there are certain restrictions for movement of this particular vehicle. Now, another aspect I want to emphasize is that, like, you know, that like India, many places, they are experiencing a lot of earthquake. And in, I think, last 2-3 months, I think some 12-13 tremors we have faced in Delhi, maybe not to that extent, but still. So when there is an earthquake, what are the elements which are going to be affected in the case of a bridge? Unlike a building where we don't want any damage in the column, but there we can easily repair or inspect and repair the beams. But here we don't want any damage to happen on the deck, but it is the pier which can be easily inspected and we can do the repair. So that's why we want to have the plastic hinge formed on the pier for the bridge, if you are following this force-based design and capacity design approach. And another approach is to isolate the bridge with the help of isolation bearing, and there are two prominent type of bearings which can be used, either a lead rubber bearing or a friction pendulum bearing. They basically extend the time period of the structure, and with because of that, the seismic demand for the bridge itself will get reduced. But sometimes it happens that the displacement of the bridge becomes quite large. So that's why they have a damping element, that is the lead plug which is there on the bearing, that is for enhancing the damping and reducing the displacement. There are other seismic protection devices like your viscous damper or shock transmission units. They are also provided in bridges, and this SP114, the guideline for seismic design of bridges, which is a recent one. And here the bridges with 100-year design life are to be designed for design basis earthquake. And one thing I want to say, that the seismic map and wind map, whatever is provided in BAS, we have to follow for the bridge design also. This is the NDMA guideline. So a seismic map as per IS 1893 part 1, then spectral acceleration graph different for elastic acceleration and response spectrum method, force-based approach amalgamated with capacity design method, and detailed elaboration on special investigation. That is, whether a bridge is close to a fault, then some site-specific investigations are required. So all such things are also given. Then there are 3 methods given for the analysis, that is elastic acceleration, response spectrum or time history, method and which are to be adopted for what type of bridges. Very clear-cut specification has been given to help the designers. Then hydrodynamic force computation or the dynamic earth pressure, that is for the design of abutment, how this can be addressed, the dynamic earth pressure, that is also given. Then what are the plastic hinge locations, where they are likely to form and how the detailing has to be done. And it is not only for the concrete structure, but also for the steel structure, this has been addressed. And the important aspect for the seismic design is that we have to prevent the unseating of the deck. So for that, like, there are some restrainers or there are certain reaction blocks which can be provided. So all these details are included in this IRC 114. And another important aspect is about the use of this integral bridge. Integral bridge means there is no bearing, no expansion joint. So you can say that the maintenance requirement is lower, and also like it has improved redundancy, and its performance under the seismic activity is quite good. And when you have less number of expansion joint and bearing, like not much traffic disruption actually happens, and also the bridge has a better appearance. And this sort of concept has been used now in UK for construction of bridges up to 60 meter, but it is gaining now popularity in India also. Now Kerala PWD, they have decided to go for this integral bridge construction. Another type of construction which is coming up in large number is the extradose bridge. Basically, this is a type of bridge which is in between, like your girder bridge and a cable stayed bridge. Though the appearance, it looks like a cable stayed bridge, but structural characteristics is more towards a girder bridge. And the girder depth is also less than that of the conventional girder bridge. But the stay cable, unlike that of a cable stayed bridge, here the stay cable tension need not be adjusted. And also the height of the pylon for the extradose bridge is maybe almost half that of the cable stayed bridge. So this is one of the bridge which has been constructed in Bihar, and it is, you can say, the short pylon, and you can see the parallel cables provided here. And the deck, of course, is not a flexible deck. So the deck behavior is somewhat similar to the girder bridge. So here a comparison of these three are given. So the interesting aspect is that in the case of cable stayed bridge, you can see that the height of the pylon is somewhat L/5 to L/4 of the span length, but here it is only L/15 to L/8. So there is a difference. And also, like, what is the depth of the deck? Here for the cable stayed bridge, it is L/100 to L/50. That is even like your 250 meter span will have 2.5 meter depth. But here it will be something like 4 or 5 meter. And also what is important is what is the maximum permissible cable stress. Here it is only 4.45 FPU, whereas in extradose bridge it is somewhat 0.6 FPU. So there are some differences between these bridges. This is another extradose bridge which has been constructed in Gujarat, and you can see here that many bridges have been constructed. I think some 25-26 bridges have been constructed so far. They have all like your box sections, especially the precast segmental boxes. They have been used, and they have been supported with the help of these cables here. Now coming to the durability based design, like what is there in IRC 112, as I told you, for the design of 100 years, like you cannot simply consider the strength alone, but also the durability is very, very important. So for that, first we have to understand how a bridge can deteriorate. because that is very, very important, because we don't want the bridge to deteriorate during the 100 years. That is our aim when we are addressing the durability-based design. So the deterioration mechanisms what have been identified are corrosion of reinforcing or pre-stressing tendon, alkali silicate reaction or sulfate attack by aggressive chemicals or acid attack, abrasion, frost attack, etc. So they have been adequately addressed in IRC 112. And what are the parameters which influence the durability? It is the exposure condition, or where the bridge is going to be constructed, whether it is in a coastal line, coastal area, or in a marine environment, or it is there interior place where there are a lot of industries around and which are emitting like carbon dioxide or sulfur dioxide, etc. Then what is the cover to the embedded steel? Because for the steel which is embedded in concrete, it is the cover which provide a protection. So the quality of concrete which is used for the cover and how good you are able to maintain the cover, they are also very, very important. Then type and quality of constituent material of concrete. I think when you start doing research with concrete, like you will understand that the more you know about concrete, you feel that I think there are many, many gray areas with the concrete, because there are so many chemical additives and all coming in the market, but we have to really understand how they really improve the quality of the concrete and how it has to be used, and how the mix design has to be done, or after the concrete is cast, concrete element is cast, about the compaction, curing and other aspect also we have to pay a lot of attention. That is the workmanship also gives needs to be paid lot of attention. Many a times you see that the bridge piers are constructed which are very massive, and after the construction you will see some gunny bags hanging on them, and somebody may pour some water, sometimes they may not. So that sort of thing cannot be allowed, and if there is a problem with water for curing, then one may have to go for some curing compounds. So the cement content, water cement ratio, all these things are very, very important. So the design of durability, the basic steps are to establish the aggressiveness of service environment with respect to the mechanism of deterioration. Different components of the bridge will have different service conditions. That is another important aspect. Select the suitable structure which is suitable. That is again like with respect to the aggressiveness, whether we have to go for a steel box or we have to go for a concrete box. So all such things become important. Select material, mix proportion, workmanship, design and detailing, and include minimum cover to the rebar. So there are 4 exposure conditions given, and to help the designer, the humidity chart is also given. So one can select the exposure condition, and the basic strategy against corrosion is the protection against corrosion is achieved by suitable water cement ratio and cover thickness. There is nothing substituting for that. So the good quality concrete you have to ensure at site, that is the low permeability concrete, that is prerequisite. So the greater impermeability that can be achieved with the control of water cement ratio and selection of cement type. You have actually OPC, PPC, PSC, then different type of cements available. So the one which you have to, the designer will have to select the suitable element for that. For example, like you have for the foundation, we are now using PPC. But for the pre-stressed concrete, we are not going for PPC, but we are going for OPC, because there the strength development with PPC is a slow process. So we may not be able to remove the scaffoldings, etc. So we go for OPC. So one has to be careful in selecting the type of the cement. Then there is a table given in IRC 112 which gives that depending on the different exposure condition, what should be the grade of the concrete minimum one has to use, then what should be the maximum water cement ratio, because the workability is also important, because we have congestion of reinforcement in many of the members. For example, like you have a box and there is congestion of reinforcement, or you have now like a very thick pier, but there is congestion of reinforcement, especially when you have the ductile detailing. There is lot of congestion of reinforcement. So what should be the minimum cement content, that is to achieve the workability and minimum cover? So all these things are prescribed, and you can see that for foundation we generally provide 75 mm cover, because foundation once constructed we are not able to inspect and do any repair. It is very difficult. So provide a maximum cover for 75 mm. So I think all these aspects I have already discussed, and also the for the serviceability check, what is the minimum crack width allowed, that is also given depending on the exposure condition. Also the chloride level in the concrete, that has also been limited. So one will have to test the water what we are using and aggregate what we are using for all these chemical, because chloride in concrete, if it is there during the construction, that will enhance the rate of corrosion much faster, and carbonation induced corrosion is slightly a slow process, but the chloride induced corrosion is just like a cancer. So there are certain additional measures which have been prescribed apart from the normal concrete cover, reinforcement cover, water cement ratio and minimum grade. That is use of high performance concrete to reduce the impermeability, and hot dip galvanized bar or fusion coated epoxy coated bar, stainless steel bar, or waterproofing membrane can be used over the deck, that is waterproofing of the deck, or using a controlled permeability formwork liner. As I told you, the cover concrete is very, very important. So how we can have an impervious cover for the bridge, that is very important, and the cathodic protection. So these are some additional measures, but one has to understand that the first requirement is to provide a quality concrete for the quality concrete for the bridge construction. There are similarly different strategies for the prevention of alkali silica reaction, because there is a lot of I think scarcity of good aggregates, and that's why like we may have to limit the cement content, to limit the total alkali content, or one may use low alkali OPC, that is which are having total alkali content less than 0.6%, or you can use fly ash at least 20%, or GGBS at least 50%, or silica fume as a part of the replacement of the cement. But what is important is test the aggregate and use non-reactive aggregate. Then for sulfate attack also, basically the sulfate is there in the groundwater or the soil, so one may have to do the testing and then use either sulfate resistant cement, or then there are certain coating materials available, because again like here there is a volume increase because of the expansion, because of the reaction products, and the strength of the concrete is likely to get reduced. So we have to pay attention when prior to we do the design. We have to do the required testing of the material or the soil. Even like you have an abutment, the backfill material what you are using, if it has a sulfate content, that can affect the abutment. Now the application, if you see, like this is the Bandra Worli ceiling, where like 50,000 metric ton of fusion coated epoxy fusion bonded epoxy coated bars have been used. Actually, like these epoxy coated bars have been in use in India for last 20 years, but one has to be very careful about its use, because the handling, transporting, etc. should not damage the reinforcement, and how we store them at site, that is also important. If pinholes are formed, then that become a local location from where the corrosion can be initiated. So one has to be very careful, because these are barrier coating. And also another problem with this type of bar is that reduces the bond strength, so we may have to provide additional development length. Then, like, we have now like 3 different admixtures, as I told you, which are allowed in IRC 112. And basically for these design and construction of bridges, we use material which are approved by BIS, and if that is not there, and but there is no restriction, but if there are certain international practices which have prescribed them, we can use them as well. So this fly ash can be used not less than 20% and not to exceed 35%. And this ground granulated blast furnace slag can also be used, and silica fume can also be used. And another new material which is coming is the nano silica. Some research going on. We also did some research and got some interesting results. So, but I think it is yet to see the actual construction. Then, like this is the Bandra-Worli sealing, where high volume fly ash has been used for tremi-seal concreting. That is 50% fly ash as replacement of the cement has been used. And there are certain advantages with when we use the fly ash for the deep foundation. Actually, when we think of bridge, we see only the structure, what is visible to us. But we have to understand many of these bridges are having like foundation which goes deep, 50, 60, 70 meter down. So the foundation protection is also important. So if we use fly ash for deep foundation, then we get excellent workability. Then it has a self-compacting and self-leveling property and longer setting time that helps in doing the concreting for a maybe 12-hour concreting. So it helps there for the long board piles, and stability of concrete can be controlled. So that is another advantage with that. Now moving to this precast construction, that is the ABC, it has better quality control because we are able to do the construction at a at a level which can be handled much easy. And also it reduces the noise and dust pollution and no requirement for staging in most of the cases, and minimum disruption of the traffic, because management of traffic for the construction, that is also a real challenge in places like Mumbai, Delhi, etc., where there is lot of traffic flying every day. Then cost saving in large project, that happen because we can use standardized element, and the same can be used for the construction. For example, this is the Barapula elevated roadway where the precast segmental construction was done. And again, as I told you, it is a continuous structure. So the continuity is there up to 4 span. And again, environmentally sustainable construction because fly ash has been used, high strength concrete has been used to reduce the carbon footprint. And there, like some 3,000 segments were constructed in 20 months. And that was possible because of the standardization of segment dimension. But where the span is sharp, in sharp curve or skew span, like there this precast construction may not be possible. So there we have to adopt the cast in situ construction. So what I want to emphasize is that you may be having an elevated roadway, but in the elevated roadway itself, like you will have both precast and cast in situ construction together. And also maybe you may have like simply supported span, continuous span, cantilever span together in one structure. And another important aspect was that the deck level was raised to 20 meters to have a vision to this Humayun tomb. And I told you this particular span, one over a railway line and one over a road, that was having a balanced cantilever construction. So the same elevated roadway will have different type of structures constructed, simply supported, balance cantilever, or continuous structure, or precast and cast in situ structure. And to help us with this precast construction, we have this IRC SP 65 and also IRC SP 71, that is for the design and construction of pre-tension girder bridges. They are not as long as 45 meter, but maybe 25-30 meter pre-tension girders. Another precast element what we use is for the RE wall of the flyovers. Basically, these you must have seen this construction also. So these are basically the panels which are tied back to the earth, filled by straps that are buried in the retained embankment during the construction, and they are lighter walls, and it can be used even when it is not possible to provide a foundation for a retaining wall. But there are certain advantages and disadvantages, and again the quality assurance during the construction is very important. Another aspect which is gaining a lot of importance is the steel concrete composite construction, where like you have the steel girders and over which like you have a concrete deck and connected together with the shear connectors. But here in this span arrangement, you will see that the space beneath the girders cannot be used for any other purpose. But here you can see that though there is some sort of a cantilevering portion, but the beneath that, because you have a narrow pier, and the portion beneath can be used again for the movement of vehicle. But how this is possible? If you see the earlier arrangement, there beneath each of the girder, like you have a bearing provided. But here what it is done is that it has been connected through a diaphragm, and then you have two-pot PTFE bearing provided to transfer the load from the superstructure to the substructure. So there is a variety of methods available for the designer. I'm sure that you have large number of students attending this webinar. I think you can have a design competition of the bridges. It will be very interesting. Another important aspect is the precast deck panel. That is also possible, and you can do the stitching of these panels. That is another aspect. And we started our presentation with arch bridge. And arch is still a very good, like I would say, a structural form, because there is no tension developing there. And this shows like how like this precast segmental arch bridge can be constructed. Either like you can have a single unit, or you can have two leaves coming, and you can have a joint at the center. And also the number of joints can be, the water tightening can be done with the help of waterproofing membrane. So this is another method by which we can do a accelerated construction. So overall, what are the developments? If I summarize, earlier we used to have cast in situ construction, we used to have a lot of delays, and now we are able to accelerate the construction with the help of precast construction. Shorter to longer spans, simply supported to continuous spans, elastomeric bearing, to pot PTFE or spherical bearing, buried sliding plate joints to single strip or modular expansion joint, normal strength concrete to high strength or high performance concrete. And apart from that, like rather than focusing only on strength, we are paying attention to the durability. Not only that, quality assurance is very important during construction. Then RCC retaining wall to cast in situ RE wall to precast RE wall. Then in urban situations, like to minimize the effect of noise, like we are providing the noise barrier for the flyovers. Then traffic management during construction is very important. Safety during construction, another important aspect. There is one IRC 87 for the safety, for ensuring the safety of the scaffolding, formwork, etc. So that is another area which the engineer has to manage at site. That is, he doesn't want any loss of time because of the happening at site. Then proper planning and shifting of utilities, because that is a great challenge for engineers, because there may be some sewer line, water line, or telephone line to be shifted, or maybe some transmission line towers to be shifted. It becomes difficult. But we have to understand that while doing the construction in site, we should not contaminate the drains or water bodies which are there by dumping the waste material. So recycling of the construction waste, that is also important. And you can see that you will agree with me that very beautiful bridge, aesthetically pleasing, this Dola Sadia Setu in Assam. And this was constructed Ministry of Road Transport under this accelerated program, and I'm sure that more number of such long span bridges will be coming. And I would like to take a leave by telling that when we build, let it not be for the present use alone. Let it be such work as our descendants will thank us for. So thank you very much for your patient listening. I hope that you are able to follow it, though it's a short time available. Thank you very much.
Thank you, madam, for a nice talk. I think any question from participant side? We will take only 1 or 2 questions because we are running short of time. Madam, there is one question.
Yes.
It is regarding Mr. Dharampal Pool has asked, ISO 39001 is a standard for road transport and road users. So he wants to know about this ISO 39001.
I'm not aware of this particular ISO, so I may not be able to answer it now.
Okay. Professor Arunachalam, you want to add something? Professor Arunachalam.
Dr. Lakshmi Parameswaran. Madam, I mean, do you have any special considerations when we are constructing a bridge in a multi-hazard zone like in Gujarat, where you have extreme wind as well as seismic activity more? In such a situation, any special consideration normally you consider? If you have, you can just.
Actually, like for the design of bridges, like we have to consider various loads, and there are something like 19 of them. And for all bridges, like we have to consider seismic, wind, and if they are there in the some water body, then the water current forces, all such things are to be considered. So even the flood in the river, that also has to be considered. So then again, like in some places it is the wind which is governing, and some places it is the earthquake which is governing. But we can understand by doing the analysis for that. And then for as I told you, the IRC SP 114 that has given like some special investigations which are required for bridges which are there in seismic zone 3, 4, and 5, especially 4 and 5. And if it is very close to the fault, then some site-specific spectra, etc., to be obtained for that. And also, we may have to consider like the ponding effect and other effect if you have a long span bridges. So that is also there. Then with respect to the wind, for special bridges like cable-stayed bridges, etc., we go for this wind tunnel testing. Then there are some special studies required with respect to the flood also, like our CPWRI in Pune, like they conduct some studies, and also the Central Water Authority, they give about the flood details for the bridge. And as I told you, the Inland Waterway Authority, they give about the barge impact. And for some bridges which are there, like where the ships are likely to come, then the ship impact also to be considered. So there are these different type of forces to be considered for the design, and that depend on where the bridge is situated and for which component these forces are to be considered. They also vary. So that's why there are more challenges with respect to the bridge design. I hope I am able to address your question.
Thank you, madam. It was a very good presentation.
Okay, thank you very much.
So thank you, madam. I think we are running short of time. So I just want to tell all attendees, though we have a lot of queries with us, madam, if you permit, we will share all the queries to you through mail, and we will reply. Yeah, it is better. So, so attendees, I will share one Google form link in which you will fill your all queries, and later on we will reply you through the mail as soon as we will get response from the madam. Madam, thank you very much. You have very well explained about the evolution of the bridge engineering and the various planning consideration, functional requirement, the aesthetic aspects, maintenance cost, life cycle cost analysis, design aspect, code provisions, extra dose bridge, etc. And we will definitely keep you, we will keep in touch with you, and we will share the queries from the participant as well. So now we have to move to the next speaker. The next speaker is Dr. Vishal Babu. Let me introduce him first. Dr. Vishal Babu did his diploma in civil engineering from Andhra Polytechnic, Kakinada, Andhra Pradesh. After that, he did his BTech in civil engineering from Sri Venkateswara University College of Engineering, Tirupati, and MTech in transportation engineering from GSITS Indore. And then he has completed his PhD from civil engineering from JP University of Engineering and Technology, Guna. He has more than 15 years of teaching experience in various organizations of repute for teaching UG and PG courses. Many students of civil engineering have been developed in their project under his guidance. He has site experience in construction of highways, canals, and multi-story building. His area of interest are highway engineering, concrete technology, and many more. He has published many research papers in various national and international journals. He is a life member of Indian Road Congress, IRC. So with this, I would like to hand over session to Dr. V.S. Babu to start his talk. Dr. V.S. Babu. Dr. Babu.
Yeah. Hello. Are you audible, sir?
Okay. Yeah.
How it will?
Your screen is appearing.
Now all of you getting the screen, sir?
Yeah, it is okay. Start.
Good morning to all. This is Dr. V.S. Babu, Assistant Professor, JUET Guna. Today my topic was weather limitations in the construction of rigid pavements. In this, I would like to mainly focus on the various remedial measures should be taken while concreting in the concreting pavements, especially in case of the cold weather and hot weather as well. Okay, mainly the construction is going on in summer season widely in India. So if you are going in the high temperature concreting, it may lead to a lot of the problem. To avoid that, we have to take the certain remedial measures while concreting. Okay, now we will discuss one by one. Now, the main contents are hot weather concreting and the second one is cold weather concreting. Next, introduction. Although India is a tropical country, previous slide. Previous slide. यारो है काम नहीं कर रहा. Okay. Next. Although India is a tropical country, many regions of the northern regions are subjected to extremely low and sub-freezing temperatures in the winter. On the other hand, ambient temperature may rise up to 40 to 50 degrees during the summer months in the southern region. That means some part of the country are subjected to cold weather and some part of the country is subjected to the hot weather. So such high and low temperatures adversely affect the properties of the concrete widely. So therefore, various precautionary measures need to be taken while concreting in this type of the weathers. Next, what is meant by hot weather? I would like to define first the hot weather. Whether it is very difficult to define the hot weather alone by using the temperature. But as per the codal guidelines, the ambient temperature above 35 degrees, relative humidity below 25%, or wind velocity more than the 15 kilometers per hour are said to be a hot weather. This is the basic definition of the hot weather. If this type of the situations occurs in the field, the necessary remedial measures must be taken by the site engineer. Next, fresh concrete temperatures combined with the high ambient temperatures, high wind velocities, and the low humidity enhance the rate of evaporation from the freshly laid surface of the concrete cements. Plastic shrinkage cracks. Generally, these micro cracks may be one of the main reasons for the damage of concrete. Generally, the rate of evaporation from the surface of concrete exceeds 1 kg per square meter per hour as per the IRC 15. The more, if the rate of evaporation is more than that specified limit, the hot weather precautions must be taken. Here, one thing I would like to say you, no concreting shall be done when the temperature of the concrete reaching the pavement site is more than 30 degrees centigrade. If you lay down over the 30 degrees centigrade, what happens? Then generally the micro cracks will be developed. Through that micro cracks, the foreign elements will enter into the pavements, and in due course of time, the durability problems will arise in the pavement. Next. Now, remedial measures against the adverse effects of the hot weather concreting. The various aspects related to materials and the mixing, placing, compaction, etc. I would like to discuss one by one. Next, water. In hot weather, the temperature of the materials, including water, is not controlled. The resulting concrete, fresh concrete, will be of high temperatures. Only increasing the water content without increasing the cement content will cause an increase in the water cement ratio, resulting in decreased strength and durability. Suppose alone water content you can't increase without the increasing the cement content. Otherwise, what happens? The water cement ratio will be increased. If you are increasing more and more water cement ratio, obviously the strength and the durability problems will arise in the later stages. Therefore, ice can be one of the best solutions. Ice can be used as a part of mixing water. Instead of water, you can use the ice. That means generally crushed ice or ice flakes are normally added in the mixer in case of the hot weather concrete. And it shall be continued until the complete melting of the ice flakes will be ensured. The quantity of ice added should be taken in the quality of ice added should be taken in the account in the total mixing water requirement. Ice should be manufactured from the non-chlorinated water. This point is important. Ice should not be manufactured from the next cement. The effect of the high temperature on the cement is that the rate of hydration of cement is increased, thus it reduces the setting time considerably. Therefore, the use of rapid hardening cement or OPC 53 grade cement, etc., should be avoided. That means in case of the hot water. These type of the two cements should not be used in case of the hot weather. But cold weather concrete you can use both. Next, aggregates. The aggregates are the main constituent parts, that is approximately 70 to 80% in the concrete. Therefore, the aggregate should be kept under the shade to protect some direct sun rays or the hot sun. Next, alternatively, some cold water can be sprinkled or the aggregate stockpile should be sprinkled by the water. That means so that you would like to bring the water. That means submergence will bring the aggregate temperature considerably low. So that after that, you can use the same aggregate in the concrete. Next, the admixtures. To reduce the water demands, the usage of the admixtures are widely used nowadays. However, some of the admixtures may cause the undesirable properties because due to the compatibility problem. Suppose some particular type of the cements will compatible with one particular type of the superplasticizers only. So you have to examine first before taking into the construction directly. Therefore, during the hot weather concreting, it is recommended that only such type of admixtures, those results you are already aware of that. Next, production, placing, compaction, and curing of the concrete. The temperatures of concrete can be reduced at the time of mixing itself by taking some basic precaution. The concrete mixer should be white painted so that it should be protected from the heat sun. Next, the construction joints should be planned well in advance to reduce the time of placement of concreting. Next, sometimes when the rate of evaporation sometimes much more, that means say for example 2.5 kg per square meter per 1 hour time, then it should be avoided to use the concreting in the daytime. At that time, go for the nighttime concreting or even in the evening time. This is the best solution if the rate of evaporation is too much. Next, in the hot summer season, generally hot hours, generally to 12 noon to 4 p.m. In between, the concreting should be avoided. At that time, if you want to particularly drop the concrete in the particular hot hours, then alternate solution is to cover with some tarpaulin stands. Some covering stand, I would like to show you a typical cover stand, just like you have to maintain a covering stand and you have to protect the concrete in the hot sun. Next, estimation of the temperature of the freshly mixed concrete. Suppose I would like to tell you one thing. Suppose you want to mix up the concrete, then what is the discharging fresh concrete? You can calculate by using the individual ingredients of the concrete. For example, I would like to explain you with one numerical also. Okay. The temperature of the freshly mixed concrete can be estimated by using the given formula, where the T is equal to temperature of the freshly mixed concrete and TA, TC, TW are the temperature of the various ingredients in degree centigrade, and S represent the specific heats of the ingredients and W represents the weight of the ingredients. Suppose the standard values, if you are considered, specific heat of aggregate and cement is 0.22 and the specific heat of the water is generally 1.0, then the above formula will reduce to very simplified way. With this formula, you can calculate the discharging fresh concrete very easily. For example, I would like to explain you the same by taking the one illustrator. For example, weight of aggregate in a particular mix is 1800 kg and the specific heats are taken as standard values and weight of the cement, weight of water is given as per the data. Then I have calculated with the help of the above formula, my fresh concrete is dropping at a temperature of say 30 degrees centigrade. Like that, you can estimate the fresh concrete temperature very easily in the site. Okay. Calculation of the rate of evaporation from the surface of concrete. Next question arises, how to calculate the rate of evaporation from the surface of the concrete pavement. If you know the rate of evaporation, if it is more than 1 kg per square meter per hour, then only the precautions are needed. Otherwise, there is no need for taking any precautions. So, first of all, I would like to explain you how to calculate the rate of evaporation from the surface of the concrete pavement. Okay. The given data required is ambient temperature and humidity and fresh concrete temperature, as I explained, and wind velocity as follows. For example, I will take one ready-made chart. This chart is available in case of the IRC 15/2017 ready chart is available. And with the illustrative example, I would like to calculate the rate of evaporation. For example, air temperature is 42 degrees centigrade and relative humidity 60% and fresh concrete is 35 degrees centigrade, wind velocity 40 kilometers per hour. With this data, I would like to explain you the procedure to calculate the rate of evaporation. Go to the chart once again back. For example, now are all of you looking my cursor? Suppose the air temperature is here. I am picking the air temperature is 42 here. From this, I am moving further forward to the top, and I will touch the curve. Relative humidity is given around how much? The relative humidity is 60%. So I will touch the 60% relative humidity curve, and after that I will move right towards the right, and I will touch the concrete temperature given as 35 degrees centigrade. From there, I can move further forward, and I will touch the wind velocity given to me as 40 kilometers per hour, and I will touch that. And after that, I will once again move further left side. So the rate of evaporation comes around to me around only the 0.94 kg per square meter per hour. So with these particular conditions, no remedial measures are required. One can ask me one simple question, sir, air temperature is 42 degrees and fresh concrete temperature is 35, wind velocity is high. But what about the relative humidity? Relative humidity is very high. That's why you are getting the low rate of evaporation. At that time, if your rate of evaporation is less than 1 kg per meter square per hour, the code says that no remedial measures are required. You can go for the concreting directly. But if your value appears as more than this 1 kg per square meter per hour, then the remedial measures, whatever the remedial measures I said, will be come into picture. Next, I will switch over to the cold weather concreting now. As a rough guideline, the ambient temperature is normally considered as cold weather as per the, that means below 5 degrees is normally considered as cold weather. This is the guidelines given in the IRC 15. Next, in view of the slow rate of setting and the strength development of concrete at low temperatures, it is essential to take some precautions measures in case of the cold weather. Do you know that the maturity concept? Generally, the high temperature obviously will increase the concrete temperature. That means maturity concept is nothing but the time into temperature. But in case of the cold weather, the problem is the setting and the strength development is the problem. Next, therefore, under any circumstances, the concreting operation should not be permitted when the air temperature less than 5, unless the engineer in charge will permit you. Suppose the engineer in charge is permit you, then you have to go for some remedial measures. That what are the remedial measures? Let we see one by one. The first, I would like to explain you the type of aggregates should be suitable for the cold weather concreting. The hard and sound and tough aggregates are suitable for the most desirable properties for the cold weather concreting. When concrete is likely to be subjected to freezing and thawing, the use of the air entraining admixtures are must. Next, rapid hardening Portland cement and high strength OPC 53 grade, etc. are suitable in case of the cold weather. High alumina cement also can be used, but with some taking by some particular precautions. Next, the use of accelerators are preferred in case of the cold weather concreting. The damage of the dosage of the calcium chloride when used as an accelerator to promote the early hardening, then its dosage should be limited to 2%. More than 2%, it is not recommended. Next, the preheating of the aggregates and water is commonly used technique in case of the cold weather concreting. Suppose in case of the hot weather, you are using the chilled water. Now, opposite to that, that means in the cold weather, you have to use the hot water. That hot water, matlab, the hot water may not increase more than the 66 degree temperature. Similarly, the maximum permittable temperature of the aggregates heating also up to 66 degree centigrade. Overheating should not be permitted. The cement does not come in contact with the hot materials directly in the mixer. No concreting should be laid at a frozen subgrade directly. You have to take some precautionary measurements while if you are found the less than the 5 degree temperatures in case of the cold weather. During the placement of the concrete, the tarpaulin covers are readily removable hazen cloth coverings must be used. The coverings may be further covered by layers of some insulating material. Next, the coverings may be so arranged that the heated air, when provided, will be circulated on the top of the pavement. Any concrete damaged by fast action should be removed as early as possible. The prior heating of the concrete transporting equipments are preferred to prevent fall in temperature during the transportation. When fresh concrete is likely to be subjected to frozen temperatures, adequate measures are to be taken to protect the concrete from the freezing by providing the thick mat or 2 or 3 layers of the hazen cloth. However, the efficiency of the above said method should be judged by using the trial sections. Next, I would like to conclude my session because now the time is very less. So I want to conclude my session. First, hot weather concrete. The ambient temperature above 35-degree temperature and relative humidity below 25% and or wind velocity more than 15 kilometers per hour are the hot weather concrete definition. If the rate of evaporation is more than 1 kg per 1 square meter per area, then only the remedial measures will come into picture. Similarly, in the cold weather concrete, the ambient concrete temperature below 5 degrees centigrade is normally considered as cold weather. Without the permission of the site engineer, you don't go to the concreting in cold weather. But if you go to the concreting in cold weather, certain precautions or remedial measures to be taken. Next, thank you. I would like to give you the question and answers now or later. In the my WhatsApp number is this and my mail ID is this. You can contact me. I am very thankful to all participants by patiently listening my lecture. Thank you one and all. Thank you, Dr. Saab. Gandhi sir, take over the.
Yes, sir. Yeah. Babu sir, Dr. Babu.
Yes, yes.
Many participants they are asking about your the sharing of your PowerPoint presentation.
Yeah, definitely, sir, definitely.
Okay, so dear participant, we will share his presentation through mail and the queries also. You just fill the shared Google form link for the queries, and we will ask your queries to the sir, and later on we will mail to you. Thank you, Dr. Babu. Now we are moving to the third speaker. He is Dr. Bhupendra Singh. He is going to talk in the area of asphalt binder characterization and grading. Dr. Bhupendra Singh is an assistant professor in Transportation Engineering Division at NIT Patna. He received his PhD from Indian Institute of Technology, Roorkee in the year 2018. He has a master degree in transportation engineering from NIT Hamirpur. His research area includes pavement material analysis and design, and he has published more than 10 research papers in reputed journals and presented 6 papers at national and international conference. He is a member of Indian Road Congress and Institution of Engineers. Dr. Singh teaches pavement material, pavement analysis, design, and highway construction practices and its maintenance. Currently, Dr. Singh is guiding 3 PhD theses. The origin of these theses lies in the sustainable pavement material and development, and he is a good research experience in pavement engineering area. So I welcome Dr. Bhupendra Singh to share and present his talk on the area of asphalt binder characterization. Dr. Bhupendra Singh.
Yes, sir. Sir, my screen is visible there?
Yes, it is visible.
Okay, thank you, sir. Hello, good afternoon all. I am Bhupendra Singh from NIT Patna, and the topic that I'm going to discuss today is asphalt binder characterization and grading. So in my presentation, I will be briefly discuss about what is asphalt binders and what are the desired characteristics that we want from the asphalt binders, and then I'll be moving on to the what are the different grading that are adopted all over the world, and how do we decide those gradings. So let me start with the asphalt grading. So one thing I want to make clear that throughout my presentation, I will be using the term asphalt binders and bitumen interchangeably because these are the terms which are used in the research also as synonyms of each other. So why asphalt binder? When we talk about the roads all over the world, most of the roads are flexible pavements which contains the bituminous top. So this bituminous top contains asphalt binders, which make asphalt binder as one of the most widely used construction material all over the world. So what is asphalt binder? Asphalt binder or bitumen is a tar-like mixture of hydrocarbons which is derived from the petroleum. It can be derived naturally or it can be derived by the manufacturing process, which is the fractional distillation of the crude oil. And most of the use of asphalt binder in the road construction, but asphalt binder or bitumen is a very good waterproofing agent also. So that is why it is used in the roofing purposes also. In the Western countries, asphalt shingles are used to line up the roof, which makes them waterproof. So when we talk about the asphalt mixes, then asphalt binders makes only 4 to 7% of the total part of the bituminous mix. So one can think that it is such a small quantity, with is it really necessary or not? But all the previous studies which are conducted to study the effect of asphalt binders on the performance of pavement has found out that the properties of asphalt binders affect the performance of the bituminous mix considerably. When we talk about the flexible pavement, there are majorly three kind of pavement failures which occurs: rutting, fatigue, and low temperature cracking. So it was found in the it is found in the research that the role of asphalt binder in rutting failure is moderate, but when we talk about the fatigue, the role of the asphalt binders becomes very critical. And in low temperature cracking, the role of the asphalt binders becomes extremely critical. So it is very important that we choose the right kind of binder for the construction of the road if we want a good performance from the road. And for choosing the right kind of road, for right kind of grade of bitumen for the construction of the road, it is very important that we grade it also properly depending upon the important characteristics. So that is why today I'm going to discuss bitumen asphalt binder grading. So first, before that, I'll be talking about some of the desired properties that we want from the asphalt binders. Asphalt binders behavior is called a viscoelastic behavior. It means the asphalt is fluid also, and your elastic solid also. And depending upon the temperature, at high temperature, it behaves as a viscous material. At lower temperature, it becomes as a elastic material. So the behavior changes according to temperature. So it is temperature susceptible, but we don't want that this behavior should not change very drastically, because if it will change very drastically, then what will happen? At higher temperature, our bitumen becomes very soft. So when the vehicle will move over it, then a depression will be formed along the wheel path, and that is called the rutting. So if our bitumen is very highly temperature susceptible, then the rutting will happen at high temperature, and on the low temperature, what will happen? Our bitumen will become very hard and brittle. So when the traffic load will come over it, it will crack under the application of that load. So our fatigue cracking and low temperature cracking will occur. So that is why we don't want that our bitumen should be highly temperature susceptible. Second thing that we want is that the viscosity of the asphalt binders at the time of mixing and compaction should be adequate. So what is the problem associated with inadequate viscosity? If the viscosity will not be proper, the viscosity that we want, then what will happen? The film that will be formed by the bitumen around the aggregate, it will not be uniform throughout. At some places, it will be very thick film, and at some places, it will be very thin film. So what problem will occur? The aggregates will not be able to bind together, and then our whatever the pavement that we are constructing, it will not be a good quality pavement. On the other hand, if we have the proper viscosity, then our binder will be able to make a uniform film thickness throughout the aggregate, and then it will result in the good bonding of the aggregates, and that will further result in the good quality of the pavement. So viscosity is a very important parameter when we talk about the asphalt binders. Then if we choose very good quality of bitumen also, and if we choose very good quality of aggregate also, but if they are not compatible with each other, so that creates a problem. So there should be adequate affinity and adhesion between the asphalt binders and aggregates. So if there is improper adhesion, there is no proper affinity between our aggregates and binders, then water will be there will be insertion of water between the aggregate and bitumen film. And if this and water is said to be the biggest enemy of our bituminous pavements. So if the water will come, then water damage will occur. So in order to avoid that, it is very important to check the affinity and adhesion between our aggregate and bitumen. So these are the basic properties, desired properties that we want from our asphalt binders. Now coming on to the asphalt binder grading. So all of the word mainly three kind of gradings which are being used. First one is the penetration grading, viscosity grading, and third one is the performance grading. Apart from this, initially chewing test was also used to be done, where the experienced person used to chew the bitumen, and based upon that they used to classify it as hard or soft or moderate. So that was long ago. Then that was replaced with the penetration grading. So let me start with the penetration grading. So penetration grading, as the name suggests, it is based on the penetration value of our asphalt binders. In India, penetration grading is decided based on IS 73/1950, and then it is further revised in the year 1961. So as we all know, what is penetration test? In penetration test, we take a small quantity of bitumen in a container, and then we make a needle penetrate this sample. The weight of the needle is 100 gram, and we allow this penetration to occur for the 5 seconds at 25 degrees Celsius. So the depth up to which our needle has penetrated our sample, we multiply it by 10 and we call it the penetration value. Let us assume that our needle has penetrated our sample by 4.5 mm. So the penetration value will be 45. And if the penetration value is 45, then our grade of the bitumen will be 40 to 50. So typical penetration grading is given as 40, 50, 60, 70, 80, 100, 120, 150, and 200 to 300. What does it denote? It denotes the penetration value of the binders. So if the penetration grading of a binder is 80 to 100, that means its penetration values will come between 80 and 100. So that is how penetration grading is done. So the lower the penetration grading, it means harder will be the bitumen. So hardest grade of bitumen according to penetration grading is 40, 50, and the softest bitumen grade according to penetration grading is 200 to 300. So penetration grading is a very simple grading procedure, but the problem associated with is that the penetration value is not any fundamental properties of the bitumen. So it creates problem because it is not related anyhow with the performance of the bitumen in the field. So that is why it was replaced with the viscosity grading. So here also, as the name suggests, viscosity grading, it is based on the viscosity of the asphalt binders, and we discussed that asphalt viscosity is a very important property. So we find out the absolute viscosity of the binder at 60 degrees Celsius, which is in terms of the poise, and then based upon that we classify bitumen in the 4 categories. So viscosity, in viscosity grade, bitumen is divided into the 4 categories: VG10, VG20, VG30, and VG40. And the document and the specification which is followed in India for viscosity grading is IS 73/2013, and this is the 4th revision of IS 73. So as we discussed that the viscosity test, unlike penetration grading, is a fundamental test which is carried out at 60 degrees Celsius. Why this 60 degrees Celsius temperature is chosen? Because this is the temperature, this is the maximum temperature which is experienced by the road pavement in the summer. So that is why we are considering 60 degrees Celsius, and we are checking the absolute viscosity, and based upon that we are grading our bitumen. So this is the table which is given in IS 73 2013, and here we can see that there are a number of tests which has been given. So these tests are penetration test, absolute viscosity at 60 degrees Celsius, kinematic viscosity at 135 degrees Celsius, flash point, solubility, softening point, and so on. So all these tests are given, but the basic test on the basis of which viscosity grade is decided is our absolute viscosity at 60 degrees Celsius. So we will conduct we will find out the absolute viscosity with the test separator, and if our absolute viscosity at 60 degrees Celsius is coming between 800 to 1200 poise, then it will be our VG10 grade binder. And if our viscosity value is coming between 1600 to 2400, then it is VG20. For VG30, this range is 2400 to 3600, and further for VG40, this range is 3200 to 4800. So this is the basic criteria depending upon which we decide what will be the viscosity grade of our binder. Apart from that, we perform the penetration test also to check the consistency, kinematic viscosity at 135 degrees Celsius is also find out because at 135 degrees Celsius temperature is generally the manufacturing temperature. So we want to check out what is the viscosity at that time, which is important when we from the workability point of view. Flashpoint test is conducted from safety point of view. Solubility is checked to check the purity of the bitumen, because if our bitumen is pure, then it will be totally soluble in trichloroethylene. So that is why this test is conducted, and the limit is also, you can check, it is 99%. The softening point to check at which temperature our bitumen gets softened, and then RTFO test is performed. So what is RTFO test? It is rolling thin film oven test, and it is performed to simulate the short-term aging. What is short-term aging? Short-term aging occurs in the field when we heat the temperature during the manufacturing process. So during this heating, some of the changes take place, and due to which our binders get hard. So we perform the RTFO test, and then we check the viscosity ratio, that how our viscosity is changing after the RTFO test. We take the viscosity before RTFO test, and we take the viscosity after RTFO test, and we check its ratio, and then the ductility test is performed. So all these tests are performed to check the different properties, but the basic criteria remains absolute viscosity at 60 degrees Celsius. And that is how our viscosity grade is decided. So when we are discussing viscosity grades, it looks that it is a very fairly decent criteria, because viscosity is a very important property also. But there is problem associated with viscosity grade and penetration grade also, because these specifications which are given, these are the empirical specifications, and there is no relation between the test results and the field performance. So that creates a problem. Because in the field, when we check, our pavement has to experience a temperature from lower temperature range to higher temperature range. In this figure, we can see that we have taken 3 samples, and we have checked its viscosity at 60 degrees Celsius. So it generally happens that at 60 degrees Celsius, your viscosity will be same. But when we talk about the higher temperature, which is the construction temperature at 135 degrees Celsius, and average service temperature, which is 25 degrees Celsius, their performance or behavior can be totally different from each other. So this deciding the grade based on the one property at one temperature does not give us full picture. So penetration and viscosity measurement may classify different asphalt with the same grading, when in fact these asphalt may be very different temperature and performance characteristics. So that is a problem which is associated with our viscosity grading and penetration grading also, because there also we are checking just the penetration at 25 degrees Celsius. So how do we solve this problem? So in order to solve this problem, performance grade came into the picture. And what is we do in the performance grade? In performance grade, I will talk what is the performance grade. First, how did the performance grade came into the existence? So performance grade came into the existence as a result of the Strategic Highway Research Program, which was a program which initiated in the year 1987 in US. And this was a 5-year program, and a total budget of the program, that the total budget which was allocated to the program was 150 millions. And the aim of this program was to improve the performance and durability of the roads in US. Out of this $150 million, $50 million of the fund was allocated for the development of performance-based asphalt specification to relate the laboratory analysis with the field performance. So a number of tests were carried out, and whatever the results that we were getting in the laboratory, that were tried to correlate with the field performance. So as a result of the SHRP, superior performance asphalt pavement characterization, which is also known as a super pave characterization, came into the existence. And what is the reason behind super pave? It is done to control the rutting, fatigue, and low temperature cracking, because these are the 3 main pavement distresses which occurs. And this study was conducted by Asphalt Institute in conjunction with FHWA. So now coming to the super pave performance grading. In the earlier grading, what were we doing? we were checking the performance at some like properties of the binder, like penetration value of, or the viscosity value at one temperature, and we were giving some of the values of that like viscosity value, range of the viscosity value. But here we have this is like total opposite to that. Here we have already decided the value of the parameter, and we check at which temperature those values can be obtained, and that is graded as the performance grade of the binder. Let me explain to you. The unique feature of the SuperPave specification is that the specified criteria remains constant throughout. For all the grades of the binder, the criteria which is there, it remains constant. So as we know that the different kind of binders have different behavior at different temperature. So now the temperature at which these criteria are achieved is called their performance grade. So the typical performance grade is given as PG 64 minus 22. So what does it denote? PG denotes our performance grade, average 7, and 64 denotes as average 7-day maximum payment temperature, which our payment will be experiencing, and minus 22 is minimum payment temperature. So SuperPave test measures the physical properties which can be related directly to the field performance by engineering principles, and test temperatures are those which the binder encounters in practice. So if a binder is having PG 64 minus 22 performance grade, what does it mean? It means it can be used at a location where highest average 7-day payment temperature reaches up to 64 degrees Celsius, and minimum payment temperature experienced is minus 22. So as far as we use this binder in this location, our payment will be able to perform better. So this is a very good criteria to characterize our bitumen. So how we reach to the performance grade of the binder? There are a number of tests and there are a number of criteria which are taken into place. We saw that in earlier considerations, only the one property was we were considering at one temperature only. But in the field, our payment has to face different climatic conditions also, and there are different payment distresses also. But in the earlier your grading criteria, we were not considering them. We were just checking the viscosity at a temperature, or we were just checking the the penetration at a test. So in performance grading specifications, all these criteria are considered, such as when we talk about the climatic conditions. So in climatic conditions, average 7-day maximum payment temperature is taken, and minimum payment design temperature is taken. From the rutting point of view, there are two parameters: one before rolling thin film oven test, and one after rolling thin film oven test. So there is a parameter that we obtain from the dynamic shear rheometer, which is called G star upon sine delta. So there is minimum value of G star upon sine delta with 1 kilopascal before RTFO, and after RTFO this value is 2.2 kilopascal. So we check, we have already fixed these criteria. Now we check at which temperature these criteria can be fulfilled, and that is called, if it is fulfilling, if we are getting these criteria at 46 degree, then it will be PG 46. If we are like this criteria is fulfilling at 52, then it is PG 52, and so on. Like that, fatigue is also a very major payment distress. For fatigue, again using the dynamic shear rheometer, we find out G star upon sine delta, and G star into sine delta. G star into sine delta is our fatigue parameter, and the maximum value for fatigue parameter is given 5000 kilopascal. Again, the same thing we will follow, in which we will check at which temperature this criteria is being fulfilled. So if this criteria is being fulfilled at 10, 7, and 4, this is called the intermediate performance grade. And then comes our low temperature performance. At low temperature performance, we conduct two tests generally. One is our bending beam rheometer, and second one with the help of the direct tension tester. And in that, we check again the criteria we have fixed, that the creep stiffness should be 30 megapascal, and we check at which temperature this is getting fulfilled. So with the help of the our bending rheometer, we get the lower temperature grade. So if this criteria is getting fulfilled at minus 24 degrees Celsius, then our performance grade will be PG 46 minus 24, and so on, depending upon at which temperature we are getting these values. So here we can see that many of the criteria, many of the practical things that our binder have to face in the field, that are accommodated in performance grading. Now, what are the different test equipments and which are used, and what are the different performance properties that they cater to? First one is the rotational viscometer. Rotational viscometer is used because we want to check what is the flow of the bitumen at construction temperature, which is 135 degrees Celsius. That is why the kinematic viscosity is checked at 135 degrees Celsius with the help of the rotational viscometer. Second one is the dynamic shear rheometer, in which again it is important to find out two important payment distress parameters. One is for the rutting, and second one is for the fatigue. And for rutting, G star upon sine delta is checked, and for fatigue, G star into sine delta is checked. Then there is bending beam rheometer and direct tension tester, and that is for to check the thermal cracking of the binder. Now I'll be giving a brief, because these tests are not such common tests, so I'll be giving the brief description of this test. So first one, we perform the RTFO. So as I told you, rolling thin film oven test, it is performed to simulate the short-term aging of the binder in the laboratory conditions. And what is short-term aging? Short-term aging occurs during the construction. When we heat the bitumen up to 150, 160 degrees Celsius, then some of the oily compounds gets lost in the heating process, and oxidation also occurs before the oxygen is there and high temperature is there, due to which the property of bitumen changes, and that is what we want to simulate in the laboratory. Then we use the RTFO. In RTFO, what we do, there are glass cylinders. In glass cylinders, we put 35 grams of samples, and we put it inside the RTFO for at the temperature of 163 degrees Celsius for 85 minutes. And we also provide the airflow of 4,000 milliliters per minute. And that is how our short-term aging occurs in the our laboratory. And then we perform test on these to check what will be the performance of our binder in the field. Second one is the PAV. Short-term aging. For short-term aging, we were using RTFO. Then long-term aging. Long-term aging occurs during the service life of the pavement. So what happens during the service life of the pavement? There will be rain, there will be UV rays which will be coming from the sun, and there will be traffic load also. So due to this, our binder property changes over the period, and this change is called aging. And the changes which occurs after the construction of the pavement is called the long-term aging, because they occur during a longer period, say 5, 6, 7, 10 years. So in order to simulate that, pressure aging Vishal test is also performed on the binder samples. So for performing PAV test, first we perform the short-term aging with the help of the RTFO test, and then we take out the sample and we put it into the PAV. Since PAV, we have to conduct the test in accelerated manner, so we increase the temperature and pressure to simulate the long-term aging in the short duration. So that test is performed for 20 hours, and we put in an oven which is having that pressure of 2070 kilopascal. Temperature that we choose can be 90, 100, and 110 degrees Celsius, depending upon the climatic condition of our location, our field conditions. And that is how we perform the PAV test. So we have performed both the aging, short-term aging and long-term aging, to simulate the aging which occurs into the field. Now we take the we check the viscosity of the binder at with the help of the rotational viscometer. We all know what is rotational viscometer. In rotational viscometer, we take the 8 to 10 graph of sample, and we put a spindle on it, and we check the torque which is experienced by the spindle at the rate of 20 RPM. And with the help of the torque, we calculate what will be the viscosity of the bitumen at 135 degrees Celsius. And with the help of that, we check whether our bitumen will be workable at the manufacturing temperature or not. Then coming to the dynamic stereometer. Dynamic stereometer is a very important and versatile piece of equipment which is used, as I told you earlier also. Fatigue parameter and rutting parameter are both decided by with the help of the dynamic stereometer. So in dynamic stereometer, what we have two plates. We can see here, these are the lower plate and this is the upper plate, and between these plate we put the sample of the bitumen, and this plate, upper plate, lower plate is fixed plate and upper plate oscillates. So while oscillating, we calculate the torque and the rotational angle is calculated, and with the help of the torque and rotational angle, we can see that the stress and strain of the binder sample is calculated, and with the help of the stress and strain, two very important and basic rheological parameter of bitumen, which are complex modulus and phase angle, are calculated, G star and delta. So as I discussed earlier, so how do we decide high temperature grade? That is with the help of the G star upon sine delta. We got the value of G star and delta from the dynamic stereometer, and we check whether this value is at which temperature this value is coming greater than 1 kilopascal for original binder, and for RTF binder the limit is 2.2 kPa. So at which temperature we will getting this value? Let's say we are getting this at 70 degrees Celsius. So our performance, high temperature performance grade will be 70 PG 70. Now for fatigue cracking, this parameter, the parameter which is used is G star into sine delta, and the limiting value is 5000 kilopascal. So we check at which value our G star into sine delta, at which temperature the value of G star upon sine delta is lower than 5000 kilopascal, and based upon that we decide what will be our intermediate performance grade. Now when we talk about low temperature performance grade, for low temperature performance grade, bending rheometer is used. In bending rheometer, a small beam of the binder sample is taken and the creep load is applied over it. So a constant load of 980 millinewton is applied, and then for 4 minutes, and we check what is the creep which is getting introduced, and with that creep we find out the value of the M and the stiffness value, and again we check there is the limiting values for this creep, and what is the slope value M that we are getting from the graph which is obtained from the log creep stiffness and log loading point. And with the help of this M value, we check at which temperature the limiting values are obtaining. Let us say at minus 22 degree of the temperature, this value is the limiting value of M is obtained. Then our performance grade will be PG 70, which was obtained from G star into sine delta minus 22. This minus 22 is obtained from bending beam rheometer. So that is how we decide what will be the performance grade of our binder. So typical performance grade which are given are like this. High grades are given PG 46, PG 52, PG 58, and so on. And low temperature grades that we are getting, it will be minus 34, minus 40, minus 46, and so on. So that is how performance grade is find out. So there are a problem associated with performance grading criteria also, but that we will discuss in some other lecture. But this is the basic criteria upon which our performance grade is decided. In the end, I would like to acknowledge the different resources from where I have taken different pictures. So I have taken pictures from Payment Interactive, different research articles, and using Google Images platform. Thank you.
Thank you, Dr. Bhupendra.
Thank you, sir.
Yes, from participant, you have any queries? Please share in the question and answer box. Please share your queries in question and answer box. Else, we will give you a Google form to write your queries, and we will send later on to the speaker. He will reply yes back, and we will forward to you later. So I will give you just 5 minutes. If you have any queries, you can share in the question and answer box.
Well, Dr. Bhupender, I have a very quick question if you can answer.
Yeah, sure, sir.
This performance grading, have we usually started using it actually in practice, or is it just in theory as of now?
No. In US, it is being used since 90s, but in India, we are still using the viscosity grading. We have not reached up to the performance grading. But in the US, it is being used since 90s.
Okay, thank you.
Okay.
Yes, any other questions from anyone?
Sir, I think we can move
Sir,
on.
Sir, Bhupen sir, there is
Yes.
one question.
Yes, sure.
What if pavement temperature exceeds 60 degrees Celsius like in Rajasthan?
60 degrees Celsius, like in Rajasthan. Yeah,
Yeah.
Practically, we consider that the maximum pavement temperature, it can reach up to the 60 degrees Celsius only. But in practical conditions, we have seen that our pavement temperature exceeds well above 60 degrees Celsius. It reaches up to the 70 degrees Celsius also. So that is why the viscosity grade that we are considering at the moment is not adequate to accommodate all the pavement conditions. That is why it is very important to move on to the performance grading. Like we can see in the performance grade, they have taken the PG 82 also. So they have taken up to the pavement temperature of 82 degrees Celsius also. So that is what this is one of the limitations of viscosity grading, and that is why we should move on to performance grading, so that we can accommodate all type of pavement conditions which are there.
Okay. Another question is, can we mix crumb rubber in asphalt? This question is from Rohit Sahu.
Yeah. Actually, crumb rubber modified binders is being used extensively. But for that, there is another IS specification, and which I have not discussed here, because this was based on the conventional binders also. And crumb rubber modified binders are very good when we talk about the high temperature performance. So rutting conditions, crumb rubber modified binders are very good when we talk about the performance. So we can definitely use crumb rubber in the with the asphalt binder.
Okay, that's enough. And now we have some other questions also, but that question will be mailed to you later on through Google form. You can reply. We will forward to the respective attendees. Right, sir?
Sure, sir. Sure.
Since we have to move ahead, now we have to move to the next speaker. He is Dr. Ankit Kathuria from IIT Jammu. Is presently assistant professor in transportation engineering section at IIT Jammu. Prior to his current job, he was teaching as assistant professor at NIT Nagpur. He did his postdoctorate research from IIT Bombay and received PhD from IIT Roorkee in year 2017. He has a master's degree in transportation planning from School of Planning and Architecture in New Delhi, and is an associate member of Institute of Town Planners, India. He also has 2 years of industrial experience prior to his PhD, during which he worked on a World Bank funded project on road safety. His research interest includes road safety, transport policy, including policies related to public transportation and intelligent transportation system. He started teaching transportation related subjects in year 2018. Along with his teaching, he has successfully coordinated 3 courses on road safety and conference till IRC Young funded by IRC and PWD Maharashtra. He has also completed a project worth rupees 14 lakh with a German firm, which is a development agency This project was based on app-based planning of public transportation routes in Nagpur city. Also, he has published 15 research papers in reputed journals and presented 15 papers at national and international conferences in the area of road safety, public transportation, and intelligent transportation system. Dr. Kathuria is presently guiding 2 PhD theses in the area of naturalistic driving behavior and power two-wheeler safety. Recently, he has started working in the area of road maintenance and rehabilitation, and also is a convener of the task force committee formed by IIT Jammu to solve the road construction and landslide problem in the Ramban Banihal section of NHAI Jammu and Kashmir section. So I welcome Dr. Ankit Kathuria to benefit us for his presentation.
Thank you, Dr. Gandhi, for a brief introduction. Without wasting any further time, I am switching to my presentation. Let me share my PPT first. Dr. Gandhi, I hope my presentation is visible.
Yeah, it is opening now. It is open.
Okay, and my
do the
volume.
Full screen. No, do the full screen. No.
Okay, I'm starting it. I'm doing full screen and starting it. Thank you.
Voice is clear.
Well, a very good afternoon to everyone. Myself, Ankit Kathuria, and I'm presently teaching in Department of Civil Engineering at IIT Jammu. So before I start with my talk, I would take this opportunity to thank Dr. Sumit Gandhi and Dr. B.S. Babu for their continuous effort that they have been putting from past 1 month to make this webinar possible today. I also take this platform as an opportunity to thank all my teachers, my gurus, the faculty members of JP universities who have imparted me great knowledge during my stay at JP University from year 2006 to 2010. So to start with the topic, this topic is basically not the core area of my research. So excuse me if I don't come up to your expectation. But yes, this topic, distress detection and maintenance of bituminous road surface, comes under a major topic of maintenance and rehabilitation of roads. So let's hope you enjoy the 40 to 42 minutes of journey. While I was digging out information about maintenance and rehabilitation of roads, I could go through some different types of codes, manuals, and specifications with somewhere talk about maintenance and rehabilitation. So I just thought that I'll, put all the list of various codes available into this one table, and I could see that, okay, there are a couple of IRC codes, there are a couple of MORTH manuals and the rural road manuals, which talk somewhere about the maintenance and rehabilitation of road. Since maintenance and rehabilitation itself is a full semester topic to be taught to the grad or undergrad student, but then the time for this talk is very limited, so I just thought I have to limit myself somewhere, and while reading it was all huge, so I just limited myself to IRC 82, which talks about code of practice for maintenance of bituminous surface. So throughout the presentation, we'll be looking at the IRC 82 in detail. To go in detail about maintenance and rehabilitation, let's look first at the definitions that are given by the IRC code. Maintenance is divided into 3 parts, which is the routine maintenance, preventive measure, preventive maintenance, or the periodic maintenance. The routine maintenance is the maintenance which happens around the year, which is maintenance such as pothole filling, repairing of cracks and patchwork, which is undertaken by maintenance staff, comes as part of routine maintenance. The second one being the preventive maintenance or preventive measure, which is a measure used to improve or extend the functional life of the pavement. And the third one being the periodic maintenance, which deals with the regular maintenance operations such as applying a renewable coat. Second, apart from maintenance, is the rehabilitation, which IRC code suggests it to be strengthening of pavement. Example being the overlay of the existing pavement comes as part of the rehabilitation. So let's look at the importance of maintenance. Why it is so important to carry out routine, periodic, or preventive maintenance. So the first importance of maintenance is reduction in rate of deterioration, which eventually increases the life of the road. Secondly, it reduces the vehicle operational cost because yes, if your vehicle has to maneuver through potholes and cracked road surface, then definitely the vehicle operational costs it increases because of sometimes aggressive braking or deceleration and other things happening. Thirdly, yes, it reduces number of accident because again, the reduction in potholes and other road failures will definitely reduce the number of accident, and also if your skid number is well in limit, definitely it has a great effect on reduction in accidents. Fourth is keeping your road traffic worthy in all weather. Yes, if you're you maintain your road throughout the year, your roads are good to go in all weather condition. Fifth is reduction in pollution due to reduced fuel consumption. If your riding quality is good, then definitely less braking will be happening, and eventually the fuel consumption will drastically reduce. And finally, it saving in budgetary expenditure of restoration and reconstruction, because yes, the continuous maintenance definitely increases the life of your pavement and thereby reducing the overall expenditure on entirely reconstructing a new road. So these are a couple of points which highlight the importance of maintenance of roads. So to start with planning of maintenance activities, as per IRC code, when we have to do a physical condition evaluation of a bituminous surface, the first thing that we have to do is selecting stretches for condition survey. So in this, IRC clearly highlights that each road should be surveyed twice a year. Once is before monsoon and once after monsoon. So based on some selection criteria, you will select the stretches on which you have to carry out the condition survey. Yes, the budgetary constraint is also one thing to carry out the same. So once the stretches are selected on which condition surveys needs to be done, the second thing is whether there is a requirement of precise condition data or there is no requirement of a precise condition data. So roads can be rural road also, it can be a urban road, it can be a national highway. So based on the category, the requirement or the precision of the condition data is required. So if there is no requirement of a very precise condition data, then we go with the green box that is seen here. So green box is that there will be a Proforma 1 which is given in IRC 82, and based on visual observations, the physical condition of the surface would be evaluated. We will see how, based on visual observation, the conditional ratings are provided. That I'll explain in the subsequent slides. So if the next box is, if it is yes, if the requirement of precise condition data is yes, then there are two ways to do it. One is by Proforma 2, which is a manual method, but in this manual method, you have to get down of your car and measure the length and breadth of the patches or the potholes and the different distress conditions which are on your pavement. On the other hand, the second, the blue box that is seen in this flowchart is the pavement surface imaging technique. So this is an advanced instrumented technique by which that you will collect the distress condition of the pavement. So these are the two ways to carry out the condition evaluation. And let's see further. Okay, well, this is the Proforma 1. When you don't require precise condition data, it's basically a visual assessment given by IRC 82. So what you see in this Proforma is that there is first the name of the road, the change of the test section, type of surface, carriageway width, date of observation, and weather condition. These are some basic data which needs to be filled for each section, or almost every section. So let's come to the table below. In this table, you can see first column tells you about the chainage. The second gives you, you have to give information about the pavement distress in form of cracks, and this value goes into percentage. This percentage value is based on your visual observation about that particular per kilometer section. Now then, the second column is about the patchwork, potholes, and similarly the other distress types which are observed in a bituminous surface. All the values are in percentages, but there is a value rut depth which is in mm. So apart from rut depth, the last column you see here is of drainage and shoulder condition, which goes as a remark. So to have an information as to how this crack, patchwork, potholes, and other distress condition it actually looks like, so I have put a couple of photographs for the same. So you can see how cracks, it can be in the form of crocodile cracking or longitudinal cracking it looks like, how patchwork look like, how potholes look like, how bleeding look like. So bleeding you can see is usually on the usual path of the wheel, because usually where the wheel moves, you know, the bleeding happens as shown in the picture. Depressions are definitely different from rutting. Rutting, you can see the photograph is shown in the end, and depression is on a particular area and is not longitudinally transferred just as rutting. So depression is one, edge breaking is one. You can see how a edge breaking distress failure occurs on the pavement. Leveling is disintegration of your bituminous surface, aggregates are visible. Shoving is bulging of your bituminous surface as seen in the photograph. Then comes the rut depth. Rutting usually happens due to the subgrade failure. As your subgrade fails, it rutting happens on the surface because of that, because it's a bottom up kind of failure. So rutting as per IRC 82 is measured using a straight edge of 3 meters. You can see there is a line diagram below the rutting photograph. So there is a straight edge, and using a measuring gauze, you observe the rut depth. Finally, it is the drainage and shoulder condition. Drainage and shoulder condition are not, they don't come in the part of the conditional rating which we'll be getting out from this data, but yes, it goes as a remark. So this is the performer 1. Let's see how performer 2 looks like. This is basically the performer 2. Again, if you don't need very precise data of condition survey, performer 1 is good to go. But if you need a precise pavement distress condition survey, then this performer 2 becomes more relevant. In performer 2, you are calculating similar information about patchwork, potholes, bleeding, but you are getting down from your car and you're actually measuring the length and breadth of the areas which are affected. So you see, let's say the crack type. So in the crack type, the type of crack, then the size, the length and breadth, and the area. So you're you're calculating. You're being a little more specific in your assessment, and based on this assessment, you will calculate the percentage of area per kilometer affected or where the distress is happening. Again, the drainage and shoulder condition goes as remarks, and rut depth is estimated in mm. So again, the rut depth is measured using a 3 meter straight edge. So this is the performer 2. Let's move ahead. Now this, like when you needed precise condition survey data, the first was the method 1, the method 2, which is the performer 2. And then the second procedure is the pavement surface imaging technique. So again, the source of this picture is IRC 82. So this is how you can see the image processing technique can basically quantify the pavement surface distress. So basically, pavement cameras are used for surface imaging, and the calibrated images, because the whatever image that the camera is collecting, you have to calibrate it to to relate it with the ground reality or the ground truth. And once your images are calibrated, you will get the length and breadth of the distressed part of the payment, and you will actually measure the percentage of the payment which are affected. Or so this is a instrumented survey, and when you need a more precise condition data, either the format 2 or the payment surface imaging technique will be used. So once we are done with the distress assessment in the payment, either visually or using instrumented techniques, the next task is to estimate the rating of the payment based on the distress. So there is a rating sheet that comes with IRC 82, and it's a very simple sheet, not very difficult to understand. So in this rating sheet, you see there is a input column here, the second column, which is one that you have to feed. There are rating as per norms which are estimated based on your input values. Basically, the range of distress varies from 1 point to 3 points. So this rating as per norms are interpolated and estimated based on the input values. A certain weightage is assigned and is shown in the fourth column here. A weightage with respect to the distress type. Okay, these weightage, the source of these weightage are from IRC 82, and based on the weightage and the input values feeded, you will calculate the final weighted rating value. Okay, based on the rating weighted rating value, you will get a final rating. Okay, which for the dummy set of input that we have used, the final rating is coming out to be 1.1, which means the condition is fair. So condition will be either poor, fair, or good. We'll look more into detail that how will we use this rating to basically further evaluate the flexible payments. So till now we have seen the rating based on the payment distresses. So the next part of evaluation comes as the functional evaluation or the writing quality evaluation. So this functional evaluation is further divided into two parts. One is the road roughness and the second is the skid resistance. So when we talk about road roughness, there are two very well-known indicators or the indexes which are used to estimate road roughness. One is the Roughness Index, which is also known as Unevenness Index, and the second is International Roughness Index, IRI. The Roughness Index is usually estimated using fifth wheel bump integrator, or the other name is Automatic Road Unevenness Recorder. Apart from fifth wheel bump integrator, car axle mounted bump integrator is also used. So the procedure to how basically the roughness index is estimated will be shown in the subsequent slide. A very brief information as to how IRI is estimated will be explained in the later slides. Coming to the second functional evaluation shown in the green box, that is skid resistance. Basically, by skid resistance, to kind of estimate skid resistance, we estimate an indicator that is skid number, and the skid number is estimated basically using skid resistance tester or the MU meter. So it's not the direct estimation of skid number. We estimate the coefficient of friction and we multiply it by 100 to get the skid number. So to start with functional evaluation, the first equipment that we have to use is the fifth wheel bump integrator. It's a very famous equipment. But while I was going through IRC 82, then to refer to the detailed procedure, we have to look at IRC SP16, which gives you in detail the procedure of carrying out the FWBI test. Now this FWBI, as you can see, for the undergrad student, I would wish to explain that this is fifth wheel because this is towed to the hauling vehicle. and it becomes fifth wheel because four wheels are already in the vehicle, so this acts as a fifth wheel. Now, there are 2-3 important points which needs to be kept in mind while doing this or while carrying out this experiment. This is the first thing is that the movement of the vehicle of the fifth wheel should be along the usual vehicle path to the best possible extent, both for the upstream and the downstream. Also, the vehicle should run at a speed of 32 plus minus 1 kilometer per hour. When the fifth wheel is moving along with the vehicle, the vertical movements are recorded by integrating unit which is connected to the fifth wheel. The vertical movements are counting in an electromagnetic counter for any inch of vertical movement. The distance is, along with this movement, the distance is also measured automatically by counting the wheel revolutions. Usually, the number of revolutions are approximately 460 per kilometer. In Indian context, I'm talking. Now, the movement of the roughness, basically the roughness index, or you call it as unevenness index, is estimated in terms of per kilometer. And you can see that I've shown a small table. It's a snapshot from the IRC SP16, which gives you some information about the condition of your road surface based on your the roughness index or unevenness index values with the type of surface. Well, the next equipment for pavement surface roughness measurement is a Merlin equipment. Initially, I got confused about with the name Merlin. So, on reading more, I could understand it's Merlin is nothing but M stands for machine, E stands for evaluating, R for roughness, L for using low cost, and IN for instrumentation. So it's a machine for evaluating roughness using low cost instrumentation and is known as a Merlin equipment. Basically, this equipment gives an index of the variation of the profile of the road along the path considered. Merlin is usually a very slow estimation of roughness because if as compared to the bump integrator, wherein the vehicle speed is almost 32 km per hour. So it is Merlin is on the other hand a manually operated equipment. Okay, and it's not suitable for evaluating long stretches. Merlin, but there is one thing. This is definitely used for calibrating response type roughness measuring machines like the fifth wheel bump integrator, because the bump readings are affected by several factors. Which can be the tension in the spring of the wheel, the tire pressure, and the condition of the towing vehicle, speed, etc. There are basically various factors which affect the readings of the response time roughness measuring machines. So this Merlin equipment is definitely used for calibrating this RT, RMM types of machines. So the principle is very, very simple to carry out the Merlin test. You see, if you see the equipment, there are two figures of the equipment. One is in the grayscale and one is in the colored thing. Any photograph you follow, basically Merlin, you can see that it has 2 feet, which are separated at 1.8 meter. And you can see there is a probe in the figure below. You can see there is a probe that is resting on the wheel track. Basically, this probe lies midway between the 2 feet. And the overall equipment is fitted with a bicycle tire. It is just for the ease of operation. So the probe that you see here, it is attached with a moving arm. Okay. Basically, this moving arm is attached with a pointer at one end, and on the other end you see it is balanced with a counterweight. Okay, so basically this arm, the moving arm, is designed in a way that it has a mechanical amplification of 10, so that if the movement of the probe of 1 mm is happening, it will produce a movement on the pointer of 10 mm. So the values are recorded in the chart, and the values that are recorded in a telebox format. And for every profile reading with the movement of the equipment, the distribution of this telebox readings are measured. Okay, and this how distributed the data get, see in the chart. It will move ahead, it will move, this pointer will come back again, it will move ahead. So a telemarking is done in that case, and the actual Merlin reading is calculated in the form of a factor D, where D is in mm. Now this D value is given in mm, and there are relationships which are developed. There is a relationship of unevenness index or roughness index with D value, which is the Merlin scale value, and also some relationships are developed with the IRI value, which is International Roughness Index value. However, the relationships that are shown here with the IRI, the D value varies from, in this case, varies. It has a constraint that D varies from 42 to some 312 value, if I'm not wrong. So yes, there are some indirect measurement of roughness index or IRI using the D values, and hence, yes, even though a low-cost equipment, it becomes a very useful equipment. So since I have introduced about IRI in the previous slide, so I'll give a brief overview about what IRI is. So IRI is an ideal roughness index, which is used and is internationally accepted. As explained earlier, that the response type systems, the roughness value that is estimated using the response type system has some, difficulties in that. Supposingly, let's say, if the roughness of a particular road profile is estimated on day X, the on day X, it might happen that the tire pressure of the vehicles and the towing vehicle condition were very different. But let's say on a day Y, using the same vehicle, the roughness was estimated when the tire pressure was different from day X. Definitely, there will be a difference in the measurement of the roughness. Similar is the case if for the same profile different vehicles are used, again because different vehicles have different properties and different suspension systems, and definitely there will be a variation in the results. So to overcome this variation, a standard index, a theoretical index was developed. IRI usually will not be estimated on field. It's basically a computer-based virtual response time system. And by virtual response time system means that the profile information is given as the input, any road profile, and based on that road profile, a theoretical quarter car or the golden car system is made to move over that profile. This theoretical golden car system will measure the vertical movement with the help of the suspension system. And the simulated accumulated motion of this suspension system divided by the distance traveled will be nothing but IRI. So the vehicle parameters which are given as input to this system are suitably selected in a way that the resulting roughness index or the IRI correlates well with the RI or the roughness index or the unevenness index value which we calculate from the bump integrator. So very quickly, I have tried to give you a brief overview of IRI. Let's see further. Moving to the next equipment, which comes under functional evaluation of the flexible pavement, is the laser profilometer. Laser profilometer is a high-speed rough surface measuring system. Because high speed, because the speed can range from 30 to 100 kmph, unlike the bump integrator where the speed was limited to 32 plus minus 1 km per hour. The measurements of the vertical displacements are done using the laser rays. Two laser sensors are used for measurement on the longitudinal profile, one on the right wheel and other on the left wheel. The good thing is the equipment directly gives IRI for both wheel paths. So I have already explained how IRI is estimated. So if the profile is available with you, the IRI can be estimated. Well, till now we have seen that in the functional evaluation, the first part is to estimate roughness, and we have seen that how using different equipments the roughness is estimated. The second important part under the functional evaluation is estimating skid resistance. So the equipment that is used to estimate skid resistance or skid number is the skid resistance tester. This tester, as you can see in the photograph, is based on the Is Rtf principle, wherein a pendulum rotates about a spindle that is attached to a vertical pillar. You can see that, but the pendulum is the pendulum arm that is shown by that red vertical arm, and the vertical pillar is just behind that vertical pillar frame. Okay, so basically there is a rubber slider attached to the pendular arm, and the loss in the energy is measured when this rubber slider is left from the catch lock portion. And the catch lock, you can see there is a lock on the top of this equipment, and from there you just have to release this pendulum arm. It will rub the surface, and the loss in energy will be estimated using the reading pointer that is shown on this equipment. The reading pointer will give you the skid resistance value. So usually this tester is suitable for laboratory specimen. For field estimation of skid resistance, it's better to go with the mu meter test, which I'll explain in the next slide. The previous equipment, which was the skid resistance tester, is majorly used for in laboratory, but in field this mu meter is usually used. This equipment is a continuous friction measuring equipment and comprises of a light weight Taylor unit, which is 254 kg and is capable of being towed just like the bump integrator. The trailer unit comprises of a triangular frame that you can see in this picture, and on which two friction measuring wheels are mounted. The equipment measures the coefficient of friction, the small f value, which is generated between the test surface and the tire, and this f value gets multiplied with 100 to get the skid number, which is which I'll explain where the skid number will be used in for evaluating the functional performance of the flexible pavement. The speed of measurement is 64 km/h, which is almost double to that of the bump integrator towing vehicle. Let's see further. So by now we know that we have estimated the roughness value in terms of mm/km, and we also have the skid number value with us. So based on these two values, we'll give the pavement functional rating. Like the previous rating was the pavement condition rating, and now the second was the pavement functional rating. This rating is also in terms of good, fair, and poor, and is divided into level 1, level 2, and level 3. Level 1 is usually for the newly constructed road, and the level 3 is for little old roads. So the SN, the skid number, as I was mentioning, it's mentioned here, can be estimated as 100 into F. The F value can be, that the F value is the value that we are getting from the previous equipment that is explained in the last slide. Let's see further. Now, till now, we have seen the rating based on two criteria. The first one was the condition rating, and the second one was the functional rating or the serviceability rating. Now, based once we have understood about these two rating systems, there are a few salient points that were given in IRC 82 before we proceed further. The first takeaway was that it is desirable that at least 2 condition surveys are conducted every year on each stretch. The first before monsoon, and second after the monsoon season. Second important point, generally the condition survey is carried out from the vehicle traveling at a speed of 5 km per hour, which is also supplemented by inspection of critical location by getting down of the vehicle and then walking. Third, condition survey may be conducted by automated survey vehicle. So it's always advised to conduct the condition survey using instrumented vehicles. Fourth being, after the condition survey, the defects shall be examined in detail, which is the next part of this code and will be discussed in detail. Fifth is, in case of rural road, periodic renewal treatment may be decided when condition rating reaches to a value of 1. So I've shown you the rating in the previous slides. The rating was ranging from 1 to 3. So this point is telling that rural road periodic renewal treatment may be decided when this rating reaches to the value of 1. In case of highway and urban roads, periodic renewal may be undertaken at a serviceability level, which was the functional rating of 2. Okay. Seventh salient point is, preventive maintenance shall be undertaken before pavement condition rating drops to 2. So whenever you are planning for a preventive maintenance, so your pavement condition rating before it drops to 2, it should be undertaken. A plan has to be drawn for preventive maintenance or periodical renewal depending upon the pavement condition rating. So IRC 82 clearly tells that a plan needs to be made, a priority to the section needs to be given based on the condition rating that we have received. So the condition rating, which is ranging from 1 to 3. So for the roads which are having 1 rating should be given the top priority, and the roads which are having 3 rating should be given the least priority. Let's move ahead. Okay, I think I've already taken 38 minutes. I'll take another 2 to 3 minutes to wind up the IRC 82 part. So when we talk about surface defects, the first type of defect was bleeding. So IRC 82 clearly gives you treatment based on the severity level of these defects on road. So first we will quickly look at the causes as to why this kind of bleeding or shiny surface appears on the road. The major causes can be excessive binder content, low void in bituminous mix, and using softer grade of bitumen, or loss of cover aggregate in surface dressing. So these are some probable reasons, and the treatments are suggested based on the severity level, the 3 severity levels that are shown here. The first severity level is low when the area of total surface is less than 1%, the bleeding surface is less than 1%, then the treatment is given by a minor, by applying a heated coarse aggregate sand, which is passing 1.18 mm sieve. So this treatment is used when the severity level is low. Similarly, different treatments are used when the severity level is medium or high. Now, in this slide, this is the next type of surface defect, which is the smooth surface, which has low resistance and becomes very slippery during wet weather conditions. So again, the IRC 82 clearly suggests you the causes and the severity and the treatment based on the severity level. So in this case, the causes are polishing of aggregate or excessive binder content, and it is divided into, the treatments are divided into 2 severity levels based on low severity and high severity, which are linked to the skid number. So this is about the flexible pavement distress. So I think already the time is rushing. Next slide, basically similar to the surface distresses, the other type of distresses are crack distresses, deformation distresses, and disintegration distresses. I'm not explaining them in detail. You can have a look in IRC 82, and in the similar way, these distresses are also, the treatments are given in the form of the severity levels. You can have a look and quickly go through it. So, 2 important other parts of this code were the preventive maintenance and periodic maintenance. So in preventive maintenance, we can see that in one line, in one blue line, I have clearly written that the right preventive measure at the right time saves the pavement from leading to poor condition. This is very well explained with this graph. You can see this graph below, wherein you can see on the x-axis is the pavement age, on the y-axis it's the pavement condition rating. Now, as the preventive maintenance treatment is, if it is taken at the right time, then the overall life of the pavement increases. So if you can see, if the pavement condition rating, the highest rating was 3, if it is 3 or near to 2, then preventive treatment is effective. If your pavement condition rating reduces to 1, then the only options or alternative that we are left with is either the rehabilitation or the reconstruction of the entire road. So preventive maintenance is very important and should be taken at the right time. Therefore, IRC 82 suggests, in the second line I've written that preventive maintenance is effective before the pavement condition rating drops to 2. This is the same rating that we have estimated. So this is one thing. Further, the preventive measures are like crack sealing, fog sealing, slurry sealing, micro surfacing, chip seal, thin surfacing, or ultra thin friction coats. So I'll quickly rush through the slides showing the different type of preventive maintenance treatment strategies. So you can have a look at the photographs, and the details are already mentioned in the slides. I will tell the conveners to share the slides whosoever wants. So I'm moving to quickly show how different type of strategy. So this is how a crack sealing looks like, and their warrants and the other details are given in the slide. This is how a fog sealing looks like. This is a slurry seal and how it looks like. This is a thin micro surfacing treatment, preventive treatment, and how it looks like. This is surface dressing. This is thin hot mix or cold mix bituminous overlay and how it looks like. This is ultra thin frictional coats and how it looks like. So the details I have already mentioned, but due to time, I'm not explaining them in detail, but these preventive measures are very, very effective if it's taken at the right time. Right time means when the condition rating drops to, before it drops to 2, these preventive measures can be taken. So I will just borrow one last minute to complete my 2 slides. So the last part of the IRC 82 code is periodic renewals. Periodic renewal basically consists of providing a surfacing layer at regular interval of time. So when do we provide this surfacing layer, or when there is a need of periodic renewal? The IRC clearly gives a couple of thumb rules for that. So I've listed those thumb rules in these points here. So in case of highways and urban roads, the periodic renewal treatment may be undertaken at a serviceability level of 2. Serviceability level, to recall, was the level obtained from roughness index and the skid number. Secondly, in case of rural road, periodic renewal treatments may be decided when the condition rating, the first type of rating that I explained, reaches to a value of 2 to 1. Then the periodic renewal requirement is there in rural roads. Apart from that, stretches showing signs of distresses such as hungry surface, hairline cracking, reveling, etc. should also be included. Finally, when the condition of road is rated as 1, supposingly the condition rating is coming as 1, then it is recommended that a detailed investigation needs to be carried out. By detailed investigation, I mean the NDT, the non-destructive testing in terms of the FWD falling weight deflectometer or the Beckelman beam test. They need to be carried out to further evaluating the strength requirements. Periodic renewal is only done when the payment is structurally adequate. So these are some couple of important points that need to be kept in mind. One last line I've written here is that roads may be arranged. So the practitioners or the engineers working in road sector, they should understand that roads may be arranged based on the ascending order of condition rating, and periodic renewal may be prioritized in the same order. So this is one important point. So these are some periodic renewal suggested treatments. So in this, you can see for a road category, national highway, where the condition rating is 2 and the roughness in mm per kilometer is 2400. The suggested treatment here is 30 to 40 mm of the bituminous concrete. Now the roughness here, that is in mm per kilometer. By now you know that it is estimated from either pump integrator. I think I have explained this in detail. So the second road category for state highway, when the condition rating is 2 and the roughness in mm per kilometer is 2800, the suggested treatment thickness in mm is either a 30 mm of bituminous concrete or 30 mm of semi-dense bituminous concrete. So in case of MDR and rural road, when the condition rating reduces from 2 to 1 and the roughness is in mm per kilometer as 4000, then 20 to 25 mm thickness of either surface dressing or a pre-mixed carpet or mixed seal surfacing is required. In case of urban roads, when the condition rating is 2 and the roughness is in mm per kilometer is 2600, 30 to 40 mm of either bituminous concrete or the semi-dense bituminous concrete or 2 coats of micro surfacing are suggested. So this is all about the periodic renewal. And let's see what we have further. Well, I think that was my last slide. I think I've taken exactly 45 minutes to cover my lecture. So thank you, everyone. You can reach out to me at kit.kathuria@itjammu.ec.in. So I hand it over to Dr. Gandhi. Thank you.
Thank you, Ankit. I will quickly take one question because one participant has requested. She is Shakshi Gupta. She is asking whether there is a relationship between roughness index, RI, and IRI, ideal roughness index.
Okay. I think, Sakshi, if you can hear me, see, there are many relationships which have been developed with RI and IRI, but you have to understand that when we talk about calibration, the more dependent value is of IRI. So, you should understand that. But yes, there are relationships available. I should have shown that, but due to limitation of time, I have not shown that. Relationships are available. I may send you a mail giving you a couple of formulas where you can directly estimate the RI or the unevenness index value based on your IRI value. Thank you.
And what is the lab cost for estimating IRI test?
I think again this is asked by the same attendee. I can see in question and answer. Well, Sakshi, IRI, the lab, it's basically a computer simulated estimation. Okay. So as of now, I don't know the exact cost, but you should understand it is not done on field. First of all, this car or the golden quarter car that I was telling you, it was not supposed to be done on field. Everything is happening in system. The only information that you're feeding for estimating IRI or to the system is the one is the profile value of your road, how the profile of road is, and some input value to that particular vehicle in terms of the suspension values and the other things. So as of now, yes, I'm not aware about the total cost of this simulated approach, but yes, I can get back to you on this. Thank you.
Okay, Dr. Ankit, I think time is not permitting us to take for some more queries. We will definitely take the queries through the Google form from the participant and we will forward to you.
Okay.
Now we are moving ahead with the next last speaker. He is Dr. Udit Jain. He is presently assistant professor at VNIT Nagpur. He did his PhD in transportation from IIT Roorkee on pedestrian safety and development of guidelines for selection of crossing facilities. He completed his master's from School of Planning and Architecture, New Delhi in 2013 and was a gold medalist in transport planning. He is an active contributor to peer-reviewed journals and various national and international conferences. His research interests are in the field of road safety, pedestrian facility planning, integration of transportation modes, sustainable transport planning, and traffic system management. He is a member of different professional bodies like IRC, IEI, and ITPI. He was recipient of MHRD Fellowship for the Higher Studies during 2014 to 2017. The work carried out by him on the pedestrian crosswalk has been incorporated in the Indian Highway Capacity Manual. The present work on the pedestrian will be of value of a revision of IRC 103, Indian Guidelines for Pedestrian Facilities. So I invite Dr. Udit to proceed or to start his talk.
Thank you, Dr. Gandhi, for this brief introduction. And before I begin my presentation, I would like to express my gratitude towards Dr. Gandhi, Dr. Babu, and Dr. Kathuria, who have, with a lot of effort, managed to plan and organize this entire webinar. So thank you so much. And with that, I will begin my presentation. Sir, is it visible?
Yeah, it is visible.
So, to all the attendees, today we have had some interesting discussions on topics related to highway planning, highway design, and we have talked about, Dr. Kathuria talked about pavement maintenance and distresses, and Dr. Bhupendra talked about characterization of bitumen. So we have been talking primarily about roads, construction of roads, maintenance of road and road materials. What I am going to talk about is also an important aspect when we talk about roads, but it is more towards the planning stage of roads. So whenever we are planning roads, road safety is a very, very important aspect that has to be taken care of. And my topic today falls under the domain of road safety, and it is a subdomain of road safety where I'll be talking about how we design safe and efficient road intersections. So we have seen that road intersections are usually one of the most common black spots where a lot of road accidents happen, and therefore it is imperative that we have proper design and efficient design of road intersections which cater to the needs of not only vehicles but also other road users like pedestrians, bicyclists, people on wheelchairs. So these are all vulnerable road users who also are the stakeholders on roads and are most prone to road accidents. So with that background, I will begin my presentation today. So first of all, I would like to talk about a project that we are working on. So we are having a memorandum of understanding with the Nagpur Smart City Mission. So Nagpur Smart City Mission has declared a corridor in Nagpur as the Smart Street. So this corridor stretches for about 10 to 12 kilometers and has a total of 18 intersections. You can see in this map. Yeah, you can see this is the smart corridor which runs from Japanese Garden Square to Orange City Square, and it has a total of 18 intersections. So one of the biggest challenges that they were having is that how well they can design these intersections to ensure that these intersections are safe and these intersections are efficient and they are integrated with the smart city mission. So these are some of the images that you can see at one of these intersections. You can see there are no proper road markings which are delineating the area which is meant for the intersection. In this image, you can see on one of the auxiliary left turning lanes, there's a footpath and there are just some auxiliary structures in the middle which are blocking the way. In this image, you can see just at the zebra crossing, there is a lamp post which is there. There is an auto rickshaw which is parked here. So these are just some common problems which we have seen that exist not just in Nagpur, but in several Indian cities, be it tier 1 cities, tier 2 cities, or tier 3 cities. And we will talk about these challenges today and what we can do to overcome them. So first, let us understand what is an intersection. A road intersection is a critical element of the road, which is a major bottleneck and a major accident spot. There are basically 4 types of intersections that we come across. The first one is an uncontrolled at-grade intersection. The second is a priority control intersection. The third is a time-separated or commonly known as a signalized intersection. And the fourth one is a space-separated or more commonly known as a grade-separated intersection. So there is a life cycle of intersections. It is not like whenever we are planning a road, we can simply go for directly a roundabout or a grade separated interchange or a signalized intersection. Depending upon the kind of roads it is, the kind of traffic there is, an intersection begins its journey with as an uncontrolled intersection. Then that uncontrolled intersection is first channelized to improve its conditions. And if the channelization does not work, then we either go for a roundabout or a signalized intersection. And if both the roundabout and the signalized intersections fail, then we move towards grade separated intersections and grade separated interchanges. We will talk about these different type of intersections and their life cycle of these intersections throughout this presentation. So first, let's see what's an uncontrolled at-grade intersection. So it is just a simple intersection between two roads which have relatively very low traffic volume. And more importantly, neither of the roads has precedence over the other. So you can see this is one road, this is second road, and both are minor roads which do not have major amount of traffic and they don't have precedence over each other. The second one is called the priority controlled intersection. So this again is a type of uncontrolled intersection, but the control here is with the help of a stop sign or a yield sign. So this intersection is usually between a major road and a minor road. In this image, you can see that this is the major road on which you can see two cars, and this one is the minor road. So a stop sign or a yield sign is given on the minor road, which automatically gives precedence to the major road. The objective is that the vehicles on the major road should not face any delay. And the meaning of a stop sign or a yield sign is that the vehicles on the minor road have to mandatorily stop and give way to the traffic on the major road before they can cross the intersection. The third one is a time separated or the signalized intersection. So I think we are all familiar with what a signalized intersection is. We must have all seen it in one of the cities that we have traveled in. So there are certain warrants for signalized intersections which are given in IRC 93, 1985, and also the heuristics are given in IRC SP 41. So these warrants and heuristics say that if the major road traffic is greater than 650 to 800 vehicles per hour and the minor road traffic is greater than 200 to 250 vehicles per hour, we can go for a signalized intersection. If these two criteria are not met, then the location does not qualify to be a signalized intersection. It will have to be a priority control or an uncontrolled intersection. So this is a typical example of the kind of intersections that we see in our Indian cities. So let me discuss a few elements of this intersection with the help of this image. So you can see that there are zebra crossings that are visible here in this image. But other than those zebra crossings, there is nothing in this intersection which meets the ideal design criteria of a good intersection. What are those criteria? Let's see. So just look at this. If you can see my pointer, you can see that during the zebra crossing, if a pedestrian wants to move from this location to this location, he would go and meet the median where there is a lamppost and the median is crossed. There is no median refuge island. If you look at this corner, so if this yellow taxi wishes to see what is there on the other side, he cannot. There are a lot of buildings and encroachment on the footpath that has taken place, due to which there is no clear visibility. The line of sight is completely blocked. Similarly, there are several issues in this intersection which you might feel that looks like a good intersection, but during the course of this presentation, we will see that this is not really a good intersection design. The fourth type of intersection is the space-separated intersection, commonly known as the grade-separated intersection. In this, the warrants are again given in IRC 92, 1985 and the heuristics in SP 41. The simple heuristic for this is if the total traffic coming from all the four arms of the intersection exceeds 10,000 PCU per hour. PCU is passenger car units. That is the equivalent number of vehicles, where we have different types of vehicles like cars and two-wheelers and trucks and bicycles. So they're all converted into equivalent car units. And if that traffic exceeds 10,000, then we go for a grade separated intersection. Okay. So now what are the factors that influence the design of these intersections? So there are four basic factors. There are human factors, there are traffic factors, road and environment factors, and economic factors. As I can see, we are running short of time. I'll skip a few things in this presentation. I will share the slides. The interested participants can look at the slides in detail. But briefly, I'll tell human factors include the perception and the decision-making time of the drivers. That affects how an intersection needs to be designed. Traffic factors means what is the traffic volume on the road, what is the pedestrian volume on the road, what is the signal timing. The road factors primarily include the geometrics of the road, the vertical alignment, the horizontal alignment, the curves, the gradients that are there. And the economic factors include the budgetary provisions and the economic feasibility of the interventions that are required at an intersection. So these are the four common factors which basically govern how we design an intersection. The basic goal behind designing an intersection, there are two goals. The first one is safety of all road users, and the second is smooth and efficient movement of traffic flow. So how we can achieve these goals is what is the basic aim behind this presentation. So let us look at what are the design principles that ensure that we meet these two goals. The first one is uniformity and simplicity. So when we are designing, we need to keep in mind the capabilities and limitations of drivers, pedestrians, and vehicles. Our designs should be based on what the driver will do rather than what he or she should do. Let me give you an example for this. So if a pedestrian wishes to cross the road from point A to point B, he will always choose the shortest path. If we are not giving a pedestrian the shortest path to move from point A to point B, no matter whatever design we do, the pedestrian is going to violate your design and he's going to take the shortest path. So these are certain things that we need to understand, that what is the behavior and perception of the road users and what they are going to do. And we should consider those parameters and incorporate them in our design to make sure that our design becomes viable. Then there should be traffic information, road signages, road markings that should be considered during the design stage itself. We have been working with a lot of agencies, PWD, NHAI, municipal corporations, and we have seen that road signages and road markings are usually not considered in the design stage. Once the road is constructed, after that they think about road signages and road markings, and then they think where to put them, how to put them. This is now not how it is supposed to be done. It is something which needs to be worked on at the design stage itself. The movement should be obvious for unfamiliar drivers, and complicated decision-making scenarios should be avoided. So typically an intersection is a 4-arm intersection, but the decision becomes quite complicated if the number of arms just increases from 4 to 5. The signal design becomes very complicated. And again, in this presentation, I will show you some grade separated interchanges which have so many dimensions that the person driving the vehicle gets confused which is the road I need to take, and the decision making for the driver becomes very difficult. So these are all the things that we need to avoid when we are designing safe intersections. The second basic design principle is to minimize the conflict points. So what are the conflict points? Let us understand that. We have to minimize the number as well as the severity of the potential conflict points. So at a typical intersection, there are a total of 32 conflict points. What are those? First, there are the 4 straight conflict points. So the vehicles that are moving in the straight direction, they make 4 conflict points. Next, we have the merging and the diverging conflict points. So at all the 4 arms, that makes it 4 and 4, 8 merging and diverging conflict points. Then after that, we have the straight to the right conflict point. So if you are taking a right turn, you will conflict with the straight moving traffic. That gives at each arm 2 more conflict points. So that gives me a total of 8 right turning conflict points and 8 pedestrian conflict points. So these in total give me a total of 32 conflict points. And as a traffic engineer, it is our responsibility to ensure that all these 32 conflict points are eliminated. So if I am providing a complete signalized intersection, I am eliminating all the central conflict points. These 16 conflict points I can eliminate if I am providing a signal. The merging and diverging conflict points I can eliminate if I am providing a dedicated left turning lane with the help of a traffic island here. And the pedestrian conflict points I can eliminate if I am providing proper zebra crossings or footover bridges or underpasses for the pedestrians to cross. So considering all these points, it is our job to eliminate all the 32 conflict points. So what are the ways to minimize these conflict points? As I said, there are two ways: space separation or time separation. So space separation basically means we give access control, we give channelizing islands, or we give grade separation, and time separation means we give traffic signals or waiting lanes. So we can minimize these conflict points. So if there's an uncontrolled intersection with 32 conflict points, we can convert it into a roundabout, which reduces the conflict points from 32 to just 12. We can convert it into a two-phase signal where two phases move simultaneously, and the number of conflict points reduced from 32 to 16. We can provide channelization. As I said, if you provide a channelizer here, the merging and diverging conflict points get removed. So a channelization can also work as an excellent example for minimizing conflict points. This is something that sometimes traffic engineers neglect, and whenever there is an issue at an intersection, the first solution that they think of is grade separation. Make a flyover and problems will be resolved. They are resolved, but grade separation is not the solution every time. There are simple solutions, cost-effective solutions like channelization, which need to be taken care of before we move towards grade separation. As I said, there is a life cycle of intersection. We have to move through the stages of the life cycle of the intersection. The next design principle is safety. So safety can be assessed by studying the frequency of the type of accidents and correlate with them with the volume and type of traffic. So a basic prioritization can be done with the help of this formula, where C is A upon under root Q into Q, where C is the severity factor, A is the number of accidents, and capital Q and small q are the volume of traffic on the major and minor roads. So with the help of this, we can create a severity factor, and we can create a hierarchy of importance, that which intersection is most severe, which intersection is less severe. And in this way, we can give a prioritization of safety. These are some of the conventional methods which were earlier used for safety. As of now, today, there are many innovative measures to assess safety. One of those measures is surrogate safety measures, on which Dr. Kathuria has done his entire postdoctoral research work. So in surrogate safety measures, we look at innovative image processing techniques in which we assess the safety at intersection by studying the interaction between pedestrians and vehicles. This is also my primary area of research, and some interesting research is being carried out in this area. Then the fourth design principle is alignment and profile. Then in alignment and profile, the intersecting road should ideally meet at right angles. The angles above 60 degree do not warrant realignment. So if it is up to an angle of 60 degree, we say it's acceptable. But if the angle of intersection goes below 60 degrees, then we always say that you realign the intersection to make sure that the intersecting angle is between 60 and 90 degrees. Then intersection should be avoided on sharp curves. Super elevation and widening becomes very complicated in intersection design. Substantial grade changes at intersections should also be avoided. We should try to keep the intersection as flat as possible. Ideally, up to 3% we say is fine if there is a grade change of up to 3%, but if the grade change exceeds 6%, it is definitely not allowed. Attendees who are interested in studying about intersection design, about safe intersection design, these are some of the IRC codes which we commonly follow whenever we are doing an intersection design problem. There is IRC 92, IRC 65, IRC 93, SP 41, SP 90, IRC 35, and IRC 67. Each of these IRC codes is so detailed, and the aspects covered in them are so important that we cover each of these IRC codes in a 1 to 2 hour lecture. So I am trying to compress all of those material today into this one lecture to give you a brief overview about what intersection design is and what is the vastness of intersection design. So let us look at some ideal designs. So as I said, the earlier intersection that I showed you was from Kolkata city. That may have looked a good intersection, but this is something which an ideal intersection should look like. So I will tell you about the elements in this intersection and why this intersection qualifies to be an ideal intersection. So let me begin with this corner. If you see, there is a dedicated left turning auxiliary lane for the vehicle. So the merging and diverging conflict has been eliminated. Then there is a channelizer island. The channelizer island completely segregates the left turning traffic and the straight moving traffic. Then you can see that there is proper chevron markings which have been made on the channelizer islands. This basically tells the drivers that there is a hazard which is there in front of you. You have to drive carefully. Other road markings that you can see are continuous zebra markings. So if a pedestrian wishes to move from any point of this intersection to any other point, there is a seamless connectivity in which the pedestrian does not have to change his grade. If you look at this channelizer island carefully, the patches in the green color, the greenery that is there, that is at a height of about 300 mm, and this concrete patch is at the road level. So if the pedestrian wishes to cross the road, he does not have to mount or dismount any curb. So the same can be utilized by a cyclist, and the same, more importantly, can be utilized by a person who is on a wheelchair. So this is something what an ideal intersection looks like. And I have given you an example of a European country, but that is not the case. There in India also, we have many ideal conditions which we are designing now and which are being implemented, at least in Nagpur city. And I will just show you some of the in the next upcoming images, some of the improvements that we have done in our cities. So this is another ideal intersection. Again, you can see there is a seamless connectivity of pedestrians with the help of zebra markings. There is also a dedicated cycle lane. You can see in yellow color, this is a dedicated cycle lane which has been made. Also, there is an integration of a bus rapid transit corridor. The peach color line that you can see is the BRT corridor which is there. So this is one of the most complicated intersection designs that you can see, which integrates several modes into the road user gambit. But still, a safe intersection design is possible even if there are multiple modes which we have to consider here. This is another way in which we tend to reduce the number of conflict points. So let's say the vehicles that are coming from the southern arm and the traffic volume moving from the southern arm to the eastern arm, that is a right turning volume. Let's say if it is very, very less. So sometimes what we do is we can restrict the right turning volume and we can force them to take a left turn and take a U-turn at this median cut and move ahead in this direction. More importantly here, what should be seen is the way the median has been cut. The median, which has a width of about 1.5 to 2 meters, has been tapered along here, and it becomes very narrow for the vehicle to turn. And with the help of a ghost lane, we slowly merge this traffic with the existing speed of traffic. So this is basically called a merging and a diverging lane, or it's called an accelerating and a decelerating lane. This ensures smooth merging of traffic, and the traffic which is coming from behind does not get disrupted because of the existing traffic. Another zoomed version of this design is to show you the channelizer island and the zebra crossing. So again, you can see here, the chevron markings have been placed across the island marker, and the zebra crossing, again, there is no grade that has to be changed by the pedestrian. If there is a grade change, you can see there is a small ramp which is here, so that there is no mounting and dismounting that takes place. Through the smooth ramp, the pedestrian, the bicyclist, and the wheelchair can access the entire zebra crossing without being able to mount and dismount the curb stones that are there. Now, this is an example of a staggered intersection. And these are all examples from Indian cities. These are ideal designs which we have made for Indian cities, and they are under implementation and under execution. So in this, you can see how a staggered intersection has been designed, and more importantly, how the bicycle lane and the footpath has been designed. So if the person has to take a left turn, why should he move to the utmost intersection location and take a left? An ideal left turn has been made for them to give them the shortest path that I was talking about. I can see some comments. I will definitely share the PPT. I request all the attendees to please focus on the presentation at the time being. Okay, so now let me talk about some practical examples that we have faced on the field. So this is an image from Bombay, And you can see the major problems that we have observed at a traffic intersection in Bombay. You can see that there is inappropriate traffic control. There is no traffic control measurements at this intersection. There is no sight distance. You can see at this corner, the person standing here cannot see what is at the other end of the intersection. There is no guidance with the help of road markings. There are several conflict points between non-motorized and motorized traffic. You can see there is a lot of pedestrian and vehicular interaction. This is absolutely not acceptable when we talk about safe intersection designs. There is overspeeding and a lot of dilemma. You can see that some vehicles are coming at a high speed, and at certain places there is choking. There is non-compliance and traffic control devices are not present. Road signs, road markings are not present. Facilities for pedestrians and non-motorized vehicles are also not provided. So this is one of the worst examples that you can see of an intersection. And unfortunately, this is the state of almost 90 to 95% of the intersection in all major cities even today. What can be the improvement? What can be the solutions? So I have classified the solutions into three parts: short-term, medium-term, and long-term. So in medium-term solutions, I can show you with the help of some examples. You can see here in this image, there is a traffic island which is there, but it does not have any chevron markings. So provide small things like road markings. In the this point number 2, you can see that below the flyover there is a parking area, and a huge width of about 20 meters has been given to this parking area to enter and exit. So this basically hinders the movement of the other traffic on the road. So we have to curtail the width of entry and exit at this parking area to make sure that the existing traffic does not get hindered. An enforcement issue you can see in point number 3, there is contra flow. Vehicles are moving in the opposite direction. Again, I say, we try to make it an enforcement issue and blame the vehicles that are moving in the opposite direction, but we need to understand why this motorist is moving in the opposite direction. The person is moving in the opposite direction because there is some origin destination pair which the designer has missed. There is a location where this motorist wants to go, and the path given to him by the designer is a much longer path which he has refused to accept and chose to break the law and take the shortest path to reach the point where he wishes to go. So again, as I said, we have to design based on the understanding of what people want and what they are going to do. So if we do that, our design becomes viable. In point number 4, you can see that the intersection is there, but there are no road markings, no zebra crossing, no kind of traffic control devices have been placed. So these are all short-term improvements that we can make at our existing intersections to make them safer. Again, we can see contra flow, opposite direction movement. We can see some auto rickshaws parked on left turning lanes. So these are again some short-term improvements we can make to make things better. Again, in this slide, we can see there is a BRTS station in the middle, but there is no place for the pedestrian to walk. Even if there is a median, the median can be slightly widened to make sure that the pedestrian at least has some space to walk. Again, if there are zebra crossings which are dilapidated, there is a need to do proper monitoring and maintenance of these road markings and other traffic control devices. More importantly, we need to understand that we have to design the city for the people and not for the vehicles. What do I mean by that? When we design, we expect that we will provide a wide enough footpath, we will provide space for the pedestrians to stand, there will be a refuge island and an ideal crossing. But even if we do that, this is what happens in reality. If there is a wide footpath, we will see that the shops will be extended onto the footpath, there will be vendors and hawkers, there will be people parking their vehicles on the footpaths, again leaving no space for the pedestrians to walk. So again, these are some issues that need to be addressed. This is taken from Bangalore. So this is one of the best practices images that I show. Now again, there is a wide footpath, and this time the footpath has not been encroached, and we have to understand why. We know that auto rickshaws and vendors and hawkers tend to encroach the footpath space. So what the designer has done is they have made a separate way for the auto rickshaws to park next to the pavement, next to the footpath. They have provided a dedicated space across the road for the vendors and hawkers to put up their stalls. So by these alternative ways, we can make sure that the footpath is not enclosed and is available for the people to walk on. Coming to some medium-term solutions, I think I'm running short of time. I'll quickly go through the medium-term solutions. The medium-term solutions include geometric improvements, and they take several weeks to achieve better efficiency. They include diversion of traffic and geometric corrections and signalization. So these are just some geometric corrections which have been made. There was a missing median, so with the help of temporary barriers, a median has been made. This is an improvement of a Viara Town junction. This was the existing condition before any improvements, and after the improvements were made, this is how the intersection looked like. You can see just by the design itself, there are so many things which have been addressed, and it has been made a much safer and efficient intersection. The second or the third short medium-term improvement is signalization. As I said, all the 32 conflict points can be eliminated if we make the signal intersection signalized. Traffic signals again are of various types. We all know about the fixed signals. Other than that, there are coordinated signals and pedestrian signals. So a coordinated signal basically means that if there are 7-8 intersections which have a traffic signal in a straight line, we design it in such a way that if you enter the green phase at the first intersection, then you will keep entering the green phase at the second, third, fourth, and consecutive intersections. This is also known as area traffic control or integration of ITS into intersection design. Coming to long-term solutions, the long-term solutions basically require considerable restructuring and higher amount of funds for long-term solutions. So, as I said, this is the Warren chart for the life cycle. So, once the priority signal fails, once the roundabout and signalized intersection fails, then we finally go to grade separation. In the life cycle of the intersection, the grade separation or the grade separated interchange is the end of the chain. And this is where, this is the final solution that you can provide after all else fails. The major type of interchanges are a simple underpass or a simple overpass, which we generally refer to as a flyover. Then we have a trumpet interchange, which is provided at a T intersection. There is a diamond interchange, cloverleaf interchange, partial cloverleaf, bidirectional interchange, and a bridged rotary. I will show you images of a few of them. So this is a simple underpass or a simple overpass, which you must have very commonly seen. This is a trumpet. A trumpet basically eliminates all the conflict points at a 3-arm intersection or at a T intersection. The trumpet itself can be of 12 to 15 types depending upon which part of the road you elevate and which part of the road you keep at grade, whether it will be a left turning trumpet or a right turning trumpet. So there is again a lot of classification among trumpets and grade separated interchanges itself. This is a diamond interchange in which we have an elevated flyover, and along with that we have an elongated rotary which runs below the flyover. Again, this is to eliminate all the conflict points. Then this is what we know as a partial cloverleaf. The image on the top, you can see this is called a cloverleaf. And here we have only 2 cloverleafs. So this is called a partial cloverleaf. And if we provide all 4 cloverleafs, it is known as a full cloverleaf intersection. Now, after the grade separated intersections, we have the grade separated interchanges. This is another level. So now here, if as I said, the dimensions of movements are multiple and you cannot fulfill them with the help of these clover leaves also, then we go for directional interchanges. So in the directional interchanges, as per the requirement and the availability of space, we can make the interchanges move in the particular directions where we want them to and make directional interchanges. It's not that this is something new, they already exist. If you have been to Delhi, at Ames, you can see there is a directional interchange in which you can move from any direction to any direction on these roads with seamless connectivity. The only difficulty is that there are some complicated decisions that the driver has to make. So we have to ensure that these directional interchanges are installed with the help of extreme amount of traffic signboards, or we know better call them as traffic control devices, and directional signboards. So that is the key behind the success of a directional interchange. Another one is the Dhola Kuan intersection. Again, if you have been to the Delhi airport, you must have crossed the Dhola Kuan directional interchange. Again, this is a very complicated directional interchange, but it works very beautifully and eliminates all the conflict points for vehicles moving in all directions. So with this, I will conclude. Thank you so much. And I hand over the mic to Professor Gandhi.
Thank you, Dr. Ankit. I think participants definitely have a number of questions with them. So anybody would like to ask any question from Dr. Udit? Either please share your question or ask to Dr. Udit directly. Any questions from panelists?
Dr. Udit?
Yes.
Just a very quick question. I think we have discussed this couple of times. It's just a friendly question.
Yes, yes.
See, I think you showed a figure wherein, when to go with a roundabout or when to go with a grade separated. So are there any thumb rule in terms of PCU values also to, take a decision on going with a grade separated intersection? Or do we go with that graph?
So, Dr. Kaduri, it's a very interesting question. And to be very honest with you, the warrants that decide which type of intersection we should provide, be it a roundabout or a signal or a grade separated intersection, the warrants for that are given by IRC SP 92. And unfortunately, these codes were developed in 1980s. So they are more than 3 decades old. So the values given in those graphs are pretty old, and the driving conditions and the vehicle characteristics were very different at that time. So today we have seen that the values that I am saying now, these are based on experience, and the IRC does not accept these values as of now. So the basic heuristics for that are that if the PCU value is up to 3,000, we can go for a roundabout. If they are up to 5,000, we can go for a signal, and if they are up to 10,000, beyond 10,000, we can go for a grade separated intersection. But these values are based on experience. The IRC code does not authenticate these values, but these are very commonly followed in transportation engineering practices all across the country.
Thank you, Dr. Udit, for a very elaborative and knowledgeable answer. Dr. Gandhi, you can take the lead now.
Yeah, Dr. Udit, there is one question from a participant named Sunny. He asked for the movement of vehicles at the intersection of 2 roads without any interference. Which type of grade separator we can use?
So the entire idea behind design of intersection is to ensure that there is a conflict-free movement. So the question is not that simple. The question says that how can we design a conflict-free movement? That depends on the amount of traffic that we have. That depends on the amount of right-turning traffic we have. That depends on the amount of left-turning traffic we have. So, as I said, the last leg of the solution is a grade separated interchange, which will solve all your problems. But that is not always the best solution. The first solution will always be to create channelizers, to create left-turning islands and auxiliary lanes, so that we can divert the traffic and reduce the merging and diverging conflict points. Even after doing that, if we feel that the safety level of the intersection has not been brought down, then we go for the next level, that is the roundabout. Then we go for a signalized intersection. Then we go for grade separation.
Okay, right. So we have a few other questions, but it is good to take those questions through the Google form and reply to the attendees later on. Right, Dr. Udit?
Right, sir.
So any other queries from the panelist? Dr. V.S. Babu? Okay. Okay, then I think I need to give some instruction to the attendees Regarding the questions from Dr. Udit, we have shared the link form, the Google form. You can fill your queries to that form, and also we have shared the feedback link form. I request all attendees, all panelists and attendees to fill that feedback form so that we may have better conduction of the webinar next time, right? And at last, I would like to ask Dr. V.S. Babu to deliver the vote of thanks to all panelists and attendees. Dr. V.S. Babu. Hello, Dr. Babu.
Audible, sir? Hello?
Yes.
Okay. Good afternoon to all. This is Dr. V.S. Babu, Assistant Professor, JUET Guna. On behalf of the organizing committee, I would like to take this privilege now to take my vote of thanks. First of all, I would like to thank Sri Manoj Gorji, Founder Chairman, and Sri Jaiprakash Gorji to establish this modern temple of learning. We would like to thank Professor J.S.P. Rai, Vice Chancellor, who has supported and motivated us in all aspects for organizing this webinar in association with IIT Jammu. We would like to thank Professor Shishir Kumar, Dean A&R, JUET Guna, and Brigadier Arjun Rawat, Registrar, JUET Guna, whose continuous efforts and words of encouragement are reflected at this occasion. We would like to thank all our speakers, Dr. Lakshmi Parameshwaran, Chief Scientist, CRRI New Delhi, Dr. Ankit Kateria, Assistant Professor, IIT Jammu, Dr. Udit Jain, Assistant Professor, VNIT Nagpur, Dr. Bhupendra Singh, Assistant Professor, NIT Patna, for accepting our requests and joined with us as a distinguished and eminent speakers today. We would like to thank Dr. Sumit Gandhi, HOD Civil, JUET Guna, Dr. Ankit Kateria, IIT Jammu, host of the session today, and Professor S. Arunachalam, Director, JP Wim Center, who have supported and encouraged us in the entire journey. We would like to thank all faculty members of the Civil Engineering Department, Dr. N.K. Samaya sir, Dr. D.K. Shukla sir, Ravindra Golia sir, Yogesh Murthy sir, and Abhishek Verma sir, and Narayan sir, and the lab staff, who has completely supported in all aspects of the webinar. We would like to thank IT cell and all the accounts department, etc., all the departments of the JUET and IIT Jammu for supporting us every time. We would like to thank all other faculty members and non-teaching staff in the both institutions. Finally, we would like to thank every participant who have attended the session and who missed the attend the session due to some other reasons. We would like to thank everyone who has supported us directly or indirectly to conduct this webinar. Thank you one and all, and have a wonderful weekend too now. Thank you.
Thank you, Dr. Babu. I would also like to mention here that we have received more than 550 entries from all over the country and some entries from outside India also. And it is a great success that most of you are present in the webinar and benefited. I request you all to please fill the feedback form because it is mandatory to get the e-certificate. I request all attendees to fill the feedback form. So now we may take the leave. It is all over from our side. If you have any queries, you can share with us later through email ID. Thank you all. Thank you very much. Thank you, panelists. Thank you, attendees.
Thank you, Dr. Saab.
Thank you, Dr. Gandhi. Thank you.
Thank you. Thank you. Thank you.
Thank you, one and all.
Thank you, Dr. Gandhi.
Thank you. Thank you, sir.
Thank you, Gandhi.